Hello everybody, am I audible? Hello. Good morning guys, good morning everybody. Just a second. Okay guys, yes, finally everything is ready. So good morning everybody once again. Everybody, hi, good morning. Jeeta, right? Ajita. Okay. Yes, Navya. Yes, Fatima. Yes, the நம்ம ரம்யா இருக்கு. Yes, da. Few names, new names are இருக்கு. எனக்கு வந்து I couldn't read da. Laikita. Okay. So இன்னைக்கு வந்து என்னடா செஷன்? இன்னைக்கு என்ன ஸ்பெஷல்? எல்லாருமே பிரேக்ஃபாஸ்ட் எல்லாம் முடிச்சிருக்கா? Breakfast done, happy, safe இருக்கிறீங்களா? Can you please let me know through the chat box guys, everybody? Everybody quickly. Hello. I'm audible, visible, everything is perfect, right? Yes da, I had. Okay, இங்க வந்து chat வரல. What happened? I don't know. One second guys, let me just try to sort this. Yes da. Mine is done. Okay, so first வந்து நம்ம class 12th வந்து இந்த மாதிரி I mean very less time ல we have finished. அதுக்கு வந்து part 1 and part 2 இருக்கு. So one session we have done in 3 hours and another one I think we have done in 2.5 hours, right? So அதோட லிங்க் தான் நம்ம description boxல first 2 links பார்த்தேன்னா lecture 1, lecture 2. அது வந்து நம்ம class 12th ஓட concept revision தான். அது வந்து we have total I think 5 to 6 hours ல we have finished. Okay, அதுக்கப்புறம் பார்த்தேன்னா நம்ம Re-NEET crash course இன்னும் few days தான். How many days left? Everybody tell me. How many days left? Yes, we have I mean இன்னைக்கு வந்து 17 தான், 18, 19, 20, 21. So 3+ days. Okay, so இப்போ வந்து இந்த daysல I mean சரியான ஒரு guidance கிடைச்சேனா lots of things will be coming. What is a perfect-ஆ வர போறோம். So அதுக்காக நம்ம free Re-NEET crash course இருக்கு. So 0 price தான், 4999 ஓட course தான் நம்ம ஸ்டூடெண்ட்ஸ்க்காக we are giving it for 0 price. So இதுல வந்து you just need to go for buy now. Okay, and the buy now if you have done na. Okay, so இது வந்து என் teacher's ID தான், so அதனால I cannot just buy. Okay, but ஆனாலும் பரவாயில்லடா, you can buy this, you can just go for buy now, then just log in with your OTP, then that's it and nothing else. Okay, so another thing is like நம்ம session முடிஞ்சதுக்கு அப்புறம் you will be having a test. Okay, post test இருக்கும். So இதுல வந்து login பண்ணிட்டேனா நம்ம my test அந்த மாதிரி ஒரு category இருக்கும். அந்த my test click பண்ணிட்டேனா நம்ம post class test கூட you can see it. Okay, so this is what I wanted to tell you guys in the beginning. So right now we are straightly going for the session. I can see the people who are watching right now, they didn't even like the session, which is unfair. Correct allada? I'm right or wrong? Okay, which is unfair. Okay, yes. Who is asking money? Very scared to face exam. Paravailada. It is asking 2 rupees. No, right now I have shown you na 0 price da. You just try in incognito mode as well. It will work. Okay, you just check it. Yes, Elvaraj, Loga, Jacob, Ashu, Ashiga, Jahi. Yes, Fatima. Okay, so now we are going to start with nama first tip. Okay, first part la vanda we will be covering nama first few chapters da. So adila vanda first chapter oda name enada? First chapter oda name enna? Quick-ஆ let me know. What is the first chapter name? அது வந்து nothing but நம்ம favorite units and measurements. Okay, how many of you like units and measurements? Quick-ஆ let me know. How many of you like? Units and measurements, ma'am. Units and measurements is my favorite chapter, ma'am. And the madri yarukavadhu irukada? Yes, 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 yes. Perfect. Okay, somebody is playing with the like button. Ennachuda? Okay. So right now we are going with the first chapter. So idhula vanda first enna nama principle of homogeneity da. Okay, principle of homogeneity solumbodhu it is nothing but the dimension of each and every term, which means if I have write an equation like this. Okay, ma'am, blackboard la black pen. Okay, so a plus b which is equal to c. If I have written now, what is the condition? Dimension of a should be equal to dimension of b should be equal to dimension of c, which means the dimension on the left hand side should be equal to the dimension on the right hand side. Correct alla? Everybody understood, guys? Marakama like pannada everybody. Yes da Nikita, we will discuss. Okay, ellame. Okay, now I understood. I was just thinking like, hey, what is this LMA? Somewhere I heard this term. Okay. Thank you. So right now, this is what the thing. Okay, principle of homogeneity. And when this... Okay, so now the thing is like, இப்போ வந்து பார்த்தேன்னா நம்ம சைனுக்குள்ள ஏதாச்சும் ஒரு டேர்ம் இருக்கு. ஓகேவா? சைனுக்குள்ள ஏதாச்சும் ஒரு டேர்ம் இருக்கு. இல்லனா நம்ம எக்ஸ்போனென்ஷியலா something is there. இல்லனா let us say logக்குள்ள ஏதாச்சும் இருக்கு. So இதுக்கு எல்லாமே வந்து இந்த பிராக்கெட்ல இருக்கிற எல்லா டேர்ம்ஸ்க்கே வந்து it is not just for sine, all the trigonometric. Okay, all the trigonometric functions, sine, cos, cosec, tan எல்லாத்துக்குமே whatever is coming in the bracket அது வந்து என்ன இருக்கும்டா? அது என்ன இருக்கும்? Please let me know. Everybody tell me. அது வந்து dimensionless ஆ இருக்கும். புரிஞ்சுதாடா? Can you give me a green forest quickly in the chat box? Everybody quickly. Yes, Varsha is here. Hi Varsha. I didn't forget your name. Okay. Yes. So இதுதான் வந்து நம்ம first part sin, log, exponential இதோட bracketல இருக்கிற அந்த quantities ஓட dimension வந்து dimensionless ஆ இருக்கும். And then நீங்க வந்து பார்த்தேனா we know that nu, okay, nu will be constant. What is nu which is equal to constant meaning? ஏனா வந்து if you are taking the measuring of physical quantity, okay, அந்த physical quantity represent பண்ணும்போது you should have two things. What are the two things? Tell me everybody, two things na numerical value irukkanum, unit irukkanum. Idu vandu eppome constant ah irukum. As I mentioned every time, ipo vandu 100 centimeter ngiradha it is equal to 1 meter da. So 100 vandu n1 na cm vandu u1 which is equal to 1 na n2 adoda unit vandu u2. So idu vandu eppome constant ah irukum. It is not going to change. Illana adu vandu correct ah da irukka porom. And also what is the relation connecting? Ipo vandu if I am asking you the relation connecting n and u na, what you will say? N and u oda connection ennada? It is nothing but n is proportional to 1 by u. Purinjudada everybody? Can you please let me know, guys, quickly? Everybody. Please respond with your favorite color. Okay, so இதுதா வந்து important ஆன one thing. Next வந்து நம்ம significant figures தான். So what is significant figures? Quickly let me know. Significant figures சொல்லும்போது அதுல வந்து all non-zero digits எல்லாமே வந்து valid தான். Okay, all non-zero digits வந்து significant தான். The confusion is only with zero. So let us say if I have a number like this 303. So how many significant figures are there? Can you please let me know? How many significant figures are there? 303 la. 303 la how many significant figures are there? Loading any issues? Can you please let me know? Yes, very good. Yena vandu 0 in between the non-zero digits vandu valid da. So now I am writing 0.03. Okay, how many significant figures? No issue. Perfect. So idhula how many significant figures irukda? Idhula vandu only 1 da irukke. Ena vandu idu vandu leading zeros da. Leading zeros with or without decimal adu vandu adu vandu consider panna. That is not significant. Another one 3300. Tell me how many significant figures? We know that 33 non-zero da. So idhula vandu 2 da. Idu vandu trailing zero da, ana vandu decimal illa. So if I am just putting like this, okay, so how many significant figures in this? Very good. 1, 2, 3, 4. Okay, idhula vandu confusion edhu illa. Non-zero digits 3 irukke, and also inga vandu oru 0 irukke. 0 is actually in between the two non-zero digits da. So it will be coming as 4. Now 33.00. How many significant figures? How many significant figures? Quickly let me know. Okay, so idla vandu trailing 0 da, ana vandu with decimal da, so this is actually significant da. So I should say 4 is the significant figures. Everybody understood? Can you give me a red velvet in the chat box? Everybody give me a red velvet quickly. So simple ana or concept da, in the examples vandu you can just note it down and you can just study. Okay va? And now the significant figures when it comes to addition. Okay, when it comes to addition or subtraction, what is the thing you will check? You will check the least decimal place. Okay, you will check the least decimal place. Okay va? So ipo vandu enkita 2.1 plus 4.22 irukke. Okay, so how you will be finding in the answer how many significant figures illana how many digits irukum? How many digits irukum? Two more examples are for especially Navya. Okay, 4.0026 and 2003.0. Tell me da. Okay, this is Navya. Okay, special. Okay, some chats I'm not getting it, but because today I'm not concentrating on the chat box, I will just concentrate over here. Okay, yes, very good. இங்க வந்து பார்த்தேன்னா நம்ம ஆன்சர்ல 1 decimal place மட்டும் தான் இருக்கணும். ஏனா வந்து addition and subtractionல what we should focus on the least decimal place, which is actually for this one. So நம்ம ஆன்சர்ல கூட only 1 decimal place மட்டும் தான் இருக்கணும். புரிஞ்சுதாடா? இது வந்து plus and minus ல இருக்கிற ரூல் தான், which means நம்ம addition and subtractionல இருக்கிறது தான். Okay va? So right now இங்க வந்து பார்த்தேனா what is the significant figures? 4, 2, 6. இது வந்து significant தான். இந்த 0 is actually in between the non-zero digits தான். So இங்க வந்து 5 தான். Okay, இங்க வந்து 5 தான். So next வந்து இங்க வந்து பார்க்கும்போது 2, 3 non-zero valid தான். And again this 0 is coming in between this, so that is also valid. இங்க வந்து again after decimal தான் நம்ம trailing 0, so which is also valid. So it is going to be 5. So answer வந்து 5, 5. Okay, how many of you got the right answer? Can you give a white chart? Those who got the right answer for the significant figures. Navya, okay vada? 5 and 4 illada? 5 and 5. Okay. Yes, Navya. Trailing 0 with the decimal illada? Yes, Shamita. Good morning. Okay, perfect. So, appadina multiplication and division varumbodhu, what is the condition? Significant figures vanda we will go for least significant figure. Okay, least significant figure. Just note it down da. Just note it down. So inga vandu paathena least decimal place da, inga vandu least significant figure da. Multiplication and division la least significant figure da. Okay va? So right now let us say I have 210 into 2340. So in the answerல எவ்ளோ what is it terms இருக்கணும்டா? answerல எவ்ளோ terms இருக்கணும்? So we will check. Okay, இங்க வந்து பார்த்தேனா இதுக்குள்ள 2 significant figures தான். இதுக்குள்ள how many significant figures? இதுக்குள்ள 3 significant figures இருக்கு. So நம்ம answerல 2 significant figures மட்டும் தான் இருக்கும். புரிஞ்சுதாடா everybody understood? Can you please let me know quick-ஆ? Everybody, I need a very fast response, guys. Perfect. So now we are going for the error part. Okay, error la vandu I will be just telling you. First vandu nama absolute error da find pananum. Okay va? So right now division la kuda same da Divya. Just on the same number, if you are dividing it also, division la you should get two significant figures mattum da. There is nothing new. Okay, ennada confusion ah irukke? இது வந்து லாஸ்ட் எக்ஸாமோட க்ளோசர் டைமில் இந்த சிக்னிஃபிகன்ட் ஃபிகர்ஸ்ல எல்லாமே வந்து டோன்ட் ஆஸ்க் திஸ். Oh my god. Okay, so just listen here. I will go slowly. Okay, so I was thought like significant figures எல்லாமே வந்து நீங்க வந்து pro. Okay, ஆனா வந்து right now I understood. So 2.03 into 5. Okay, so tell me how many significant figures in the answer. Don't do the calculation and all. Tell me how many significant figures will be there. Quick-ஆ ஏன்னா வந்து we will check. Okay, இதுல வந்து 3 significant figures தான் இருக்கு, இதுல வந்து 1 significant figure தான் இருக்கு. So நம்ம ஆன்சர்ல கூட only 1 significant figure தான் இருக்கணும். Understood? Can you give me a green forest everybody? Yes, perfect, perfect. Don't say 3, Ankita. Okay, it is actually 1. So right now another one. I'm just going for 5 divided by 3.0. Okay, so 5 ila 1 significant figure da. Idhula vandu pathena how many significant figures irukada? In 3.0 la how many significant figures? 2 significant figures irukku. So நம்ம ஆன்சர்ல எவ்வளவு significant figures இருக்கணும்? நம்ம ஆன்சர்ல எவ்வளவு significant figures இருக்கணும்? We will be having only 1 significant figure in the answer. புரிஞ்சுதாடா everybody? Yes or no? Can you please let me know quick? Everybody. Okay, so now quickly we are going for the error part. Okay va? Yes, answer with 1 significant figure. Very good, Jehi. Yes, 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 Jacob. Very good. Yes, Fatima. Yes, yes, Burmi. Okay, anyway, whatever it may be. So நம்ம வந்து we are going for the error. So first வந்து நம்ம absolute error தான் நம்ம வந்து find பண்ண போறோம். So அதுக்காக நமக்கு வந்து readings இருக்கு, A1, A2, A3, etc, etc, AN. இந்த மாதிரி readings இருக்கு. So first what you will do? First step என்னடா? We will find the mean value. Okay, we will find the mean value. What is mean value? A1 plus A2 plus A3 plus etc etc AN divided by number of readings. அதுக்கப்புறம் you will be finding the error in each term. அது வந்து modulus value தான், which means after subtraction, even if you are getting a negative value nalu, you will consider the positive value, which means A1 minus in the mean value. Okay, in the mean value. Like this way you will go for the rest of the terms as well. So A2 minus A mean. So idhula vandu you can just do A mean minus A1, A mean minus A2. Adu kuda pannalam, because there is no point of what is a negative positive, which is going to be bigger value. Adula vandu what is it, there is no problem. You will find the rest of the terms as well. Adukapra you will be finding the mean of these values, which means delta A1 plus delta A2 plus etc etc number of terms that is coming as n. So whatever you get it over here, this is what our mean absolute error. So ipo vandu if you wanted to write the reading, final reading, FR na final reading. Okay, so in the final reading if you wanted to write na, what you will say, you will write this mean value, idudha vandu nama true value plus or minus nama error. Okay, nama absolute error we got. This is how we will be representing a reading. If you got any reading, so adula vandu first you will write the mean value, adukapra adula irukra chances irukra and error oda range da vandu we will be just mention over here. So next final reading vandu mudinjirukke. Next vandu relative error da. Relative error vandu how you will be finding? Relative error how you will be finding that? Can you please let me know? So it is nothing but nama mean absolute error divided by nama true value da. Ipo vandu percentage error find pannanomna how you will find? Nama relative error into 100. Okay, this is what the step. Everybody understood? Can you please let me know, guys? Everybody please respond quickly. Everybody please respond. Everybody just respond with a white forest quick. So இப்போ வந்து பார்த்தேனா you have a kind of, you got an equation, இல்லனா you got a value that z is equal to a plus b. Okay, or z is equal to a minus b. இதுல வந்து error find பண்ணனும்னா what you will do? You will find the error in a, you will find the error in b, and then you will add. Okay, even if it is in subtraction also, error will be always added up. Okay, நம்ம relation வந்து subtraction ஆ இருக்கட்டும், இல்லனா what is addition ஆ இருக்கட்டும், but definitely what is the thing? Errors will be always added up. இப்போ வந்து z is equal to a minus b நாலும் நம்ம z ல இருக்கிற error வந்து delta a plus delta b ஆ இருக்கும். What is delta a? Error in a. What is delta b? Error in b. அது வந்து subtraction ஆனாலும் what is addition ஆனாலும் same தான். Error will be added up always. இப்போ வந்து multiplication வந்துட்டேனா, okay, multiplication வந்துட்டேனா நம்ம relative error in this value will be delta z by z will be delta a by a plus delta b by b it will come. So if there is a power, okay, இப்போ வந்து இதுக்கு வந்து power இருந்துருச்சுனா, let us say this is a square, அப்படினா you should multiply 2 here. இப்போ வந்து இங்க இருக்கிறது b cube. So அப்படினா you should multiply that power as well. Same for division as well. Okay, same for division as well. So divisionல கூட இப்போ வந்து I have a function like this, a square divided by b square. Now I wanted to find the what relative error. What is going to be that? Even if it is division, delta z by z will be 2 power into error, relative error of a plus inga kuda plus da ena vandu errors will be always added up. Okay, errors vandu eppovume it will be added. So again power of b vandu 2 da, adu vandu you will be having a confusion, ma'am minus 2 podnama. No da, you should go for plus 2 and then delta b by b will be the answer. Okay, so same problem da, inga vandu a square b square, inga vandu a square by b square, ana vandu relative error vandu same da. Understood? Can you give me a yellow heart everybody? Everybody give me a yellow heart. So adukapram pathena, if you wanted to find the percentage error, what you will do? You will just multiply with 100. The whole term you will be multiply with 100. Aval Mohan, adoda link வந்து நம்ம description boxல first 2 links இருக்குடா class 12 க்கு. You can just watch that. Okay, இது வந்து class 11th மட்டும் தான் இருக்க போறோம். Okay, perfect. So அப்படினா guys, don't forget to like the session as well. So right now we are going for our Vernier caliper. Okay, Vernier caliper சொல்லும்போது first வந்து we should understand what is least count. Okay, least count will be 1 MSD minus 1 VSD da. Okay va, 1 MSD minus 1 VSD da. So don't get confused. MSD and MSR is different. VSD and VSR different. Can you please let me know what is that? What is that? MSR, MSD, VSR, VSD. என்னடா அது? Main scale division da actually வந்து MSD. Which means let us say இப்போ வந்து நம்ம scale இல்ல, so அதுல வந்து இதுதான் வந்து 0 1 2 3 4 5 6 இந்த divisions. Okay, இப்போ வந்து நம்ம what to say நம்ம pointer. Okay, pointer is actually இங்கே தானா, then I will say this is 1 2 3 4 5. Okay, 5 da reading and division வந்து different da. Okay va, so right now least count வந்து 1 MSD minus VSD da. அதுக்கப்புறம் you will, I mean நம்ம questionல ஒரு relation இருக்கும். ஓகேவா, n VSD will be coincide with n minus 1 MSD. அப்படினா what you will do? n VSD which coincide with n minus 1 MSD. So what you will do? You will find 1 VSD first. ஏன்னா வந்து we know that நம்ம least count ஓட value என்ன? 1 MSD minus 1 VSD தான். So of course we cannot just directly subtract. Okay, 1 MSD ல இருந்து MSD மட்டும் தான் we can just subtract. 1 VSD ல இருந்து VSD மட்டும் தான் we can subtract. So அப்படினா VSD வந்து we need to rewrite in terms of MSD. அதுதான் வந்து இந்த ஒரு ஸ்டெப்ல we are doing. 1 VSD will be coming as n minus 1 divided by n MSD. அதுக்கப்புறம் you will be substituting the value over here. Are you guys getting what I'm saying? Can you please respond with your favorite heart, guys? Everybody? So now we will be getting the what? Nama least count kadichirukku. அதுக்கப்புறம் நம்ம final reading, if you wanted to write the final reading na, what is the step? So first வந்து instead of don't think like அந்த MSD தான் இங்க வந்து substitute பண்ணணும், இல்லடா main scale reading. Okay, main scale reading நம்ம Vernier ஓட 0 இல்லடா, Vernier scale ஓட 0 will be coming in between any of these lines. Okay, any of these lines. அந்த ஒரு பாயிண்ட் தான் main scale reading. Okay, main scale reading plus VSR. Okay, VSR which means ஏதாச்சும் ஒரு line of நம்ம Vernier scale will definitely matches with the main scale, what is in the main scale. So that is what VSR into LC minus 0 error. Got it everybody? So this equation is very important. Nama screw gauge or Vernier vanda every year mostly if I'm taking last 10 years adala vanda it is asked multiple times. Okay, so please be what is please you have to go through this equation. Now coming to the screw gauge சொல்லும்போது அதோட least count வந்து pitch divided by the number of divisions in the circular scale தான். So usually வந்து the number of divisions in the circular scale வந்து 100 தான். ஆனா வந்து there are some screw gauge which is having which is having 50 as well. Okay, circular division வந்து நம்ம screw gauge ல நம்ம rotate பண்ணும்லடா அது வந்து 100 ஆ இருக்கலாம் இல்லனா 50 divisions இருக்கலாம். ஓகேவா? So mostly it will be 100. So always just check what is given in the question paper. Don't just approach with a prejudiced mind. It will be given. If it is not mentioned, you can just consider it as 100. But if it is mentioned, be careful. 100 can also come, 50 can also come. Okay, so அப்படினா what is this pitch? So we know that there is a linear scale and there is a circular scale. Correct illa? So ipo vandu paathena nama in the linear scale la when I am just rotating this, okay, when I am just completing one rotation, definitely there will be some kind of displacement which is happening in the linear scale. That is what actually the pitch. Okay, when I am completing one circular motion, one circular in the circular scale vandu when I am rotating it for the complete one rotation ku appuram, what is the linear displacement? That is what nama pitch. And final reading la enna irukuda in the linear scale la irukra reading plus circular scale la irukra reading into LC minus 0 error. Understood everybody? Everybody understood? In the time la keka vendiya question that screw gauge is used for. Okay, screw gauge is used for what to say to we need to study something illada adukkaga da. Hey, small ana things வந்து measure பண்றதுக்கு தாடா. Okay, least count சின்னதா இருக்கேல. So இப்போ வந்து நம்ம what to say the normal scale we have adu paathu we can just find up to 1 millimeter accuracy la mattunda we can just measure something. Ana vandu when it comes to screw gauge, when it comes to vernier, we can just measure even with lesser value. Got it? Understood everybody? Yes, exactly. Okay, ipo vandu nama paper oda thickness find pananum, and also in the screw gauge ellame vandu biology la kuda you people are using. Correct ah? Edo something you will be just measuring. I forgot about it. Screw gauge vandu biology la kuda you are using. Okay, so idudha vandu nama what is the units and measurements la irukke. Now straight ah vandu we are going for the straight line. Okay, straight line la poga poro. So right now just give me the equations. So first one we know that nama velocity vandu dx by dt. Okay va, dx by dt. So ipo vandu if I'm just doing v dt, okay, if I'm doing v dt, what will happen? Everybody tell me. Ipo vandu I'm just telling you, just simple ah sollitena, just understand. இங்க வந்து displacement இருக்கு, இங்க வந்து velocity இருக்கு, இங்க வந்து acceleration இருக்கு. Okay வா? If I am differentiating this, which means dx by dt பண்ணிட்டேனா I will be getting velocity. If I am doing dv by dt, I will be getting acceleration. If I am going for integral a dt, I will be getting velocity. If I am going for integral v dt, I am going to get this. Everybody understood? Yes or no? Yes or no? Yes or no? Everybody? 1 minute screenshot. Screenshot ku ellame vandu 1 minute theviyada. And guys, marakama like pannada. You people are not liking the session. Hey, இதெல்லாமே வந்து பண்ணிருக்கேன்டா. Why you are just last minute la ma'am இந்த வீடியோ போடு ma'am, அந்த வீடியோ போடு ma'am. It is already there in the channel. Okay, you can just watch it. So this is what the thing. Now another thing is nothing but okay da, enakku theriyunda, you people have already like ungalku vand reminder edum thevilla, that I know. Okay, so right now this is what the thing. And also in the acceleration ku vandu one more equation is there, that is nothing but v into dv by dx. This is also an important equation. Okay, so next vandu nam average velocity and average speed oda equation da. Okay, average velocity, quick let me know what is the equation. Everybody, average velocity and average speed oda general equation. Average velocity சொல்லும்போது the net displacement divided by time da. Average speed சொல்லும்போது the total distance divided by time. So if you know this equation, you can do all the questions which is coming under this. Okay, even we have studied equal segments. If you are covering equal distances with different velocities, which means I'm just traveling from A to B, okay, then B to C, then C to D. If AB is equal to BC is equal to CD, I can just find the average value. Okay, what is the average value? 1 by v1 plus 1 by v2 plus etc. If in this case AB is equal to BC is equal to CD, what is n value? Can you please let me know? So ipo vandu I mean, in the equation kuda we are getting from here only. Okay, so just understand this equation. Edachu or question came for average velocity, average speed, definitely that will be based on this equation da. If you can't do anything nalum, just try to find total distance, just try to find the net displacement from the given data. Very good, Fatima. Idu vandu it is coming as 3 da. Okay, n will be coming as 3 da. So 3 divided by v average will be coming as whatever be the individual velocities. Purinjidada, everybody? Can you just respond with your favorite emoji? Everybody, quicka. I wanted to know. Quickly, you can give it to me. Okay, so next one நம்ம equations of motion da. Equations of motion சொல்லும்போது v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. One more we have the modified one da. Nama s vandu we are finding it for only a particular second. Okay, only for a particular second. Okay, so that is nothing but u plus a by 2 into 2n minus 1. So this is what the equations of motion that we should study in the what is a motion in a straight line chapter. Okay vada, everybody understood? Yes or no? Amada kappu mukyam da. Okay guys, you people are not liking the session, which I don't like da. Like the session quicka. Perfect. So now we are quickly going for the graph. So first one, the displacement time graph da. So I'll draw here. You people will say what is represented by A, what is represented by B and all. Okay. So Kikka, you can just tell me. Ellame vanda nama position time graph da. So tell me what is this graphs represents. Okay, so first one pathena, position is not changing with the time. This is x, this is t. Okay, position is not changing with time. So appadina 3 conchoose not liked, ma'am. Yarada Ramya. So idu vanda position change agala. So this is representing rest. What will be the velocity? What will be the velocity? Yes, very good, Divya, very good. The velocity will be coming as 0. And what is happening here? What is happening here? This is actually, okay, the slope of a displacement time graph on the velocity da. So inga vandu paathena nama velocity is actually constant, and you can see the angle theta. Okay, angle theta. Slope na we know that tan theta da. Tan theta will be positive. Okay, tan theta will be positive when theta is acute. Acute na enada less than 90 degree ana mattum da actually vandu idu vandu positive agum. So appadina in the slope vandu positive illa negative? Quickly let me know. So idu vandu definitely positive. Now tell me what about C? C, D, E ellame irukku. So quick let me know da. Quick. So C vandu again velocity vandu constant, slope vandu constant, but ana vandu idu vandu negative da. Ena vandu nama angle is theta is actually obtuse, so tan theta will become negative. Okay va? And in the case la enagum, I will be just check. We know that V is not constant at all. Okay, I will just check this slope. Okay, I will be just check this slope. So over point ilume nama theta value is actually increasing. Correct alla? Theta value is increasing. So tan theta is increasing, and now I can say that this is a velocity increasing graph. Okay, velocity increasing graph. Can you please let me know what will happen here? Here also I will be finding the slope. So what will happen da? In the point la paathena nama theta is actually reducing. Okay, reducing sollumbodhu what will happen? Reducing sollumbodhu what will happen? Yes, we know that nama velocity again not constant da, and this is actually a decreasing velocity. The velocity initially velocity irundiruchu, ana vandu after some time it will reduce and it will be coming to 0. Understood? Can you give me a green forest quickly in the chat box, guys? Everybody, if you want, you can just take a screenshot as well quickly. And also class 12th oda இந்த மாதிரி concept revision வேணும்னா நம்ம description boxல first 2 links இருக்கு, part 1 and part 2. அது வந்து watch பண்ணலாம்டா. So almost 5 to 6 hours we have finished that lecture. Yes, perfect. So appadina now we are going for the velocity time graph. So you can just tell me, I will be going for this. Okay, just mention what is A, then B, then like that way. Okay va? Velocity time da. So quick let me know, guys. Quick let me know. What is happening here? Time is going, but ana the velocity remains the constant. So I can say that V will be constant here. Oh my God. Yeah. Okay. V is constant here. And what is the slope of a velocity time graph? What is the slope of a velocity time graph? What is that? That's nothing but acceleration. Okay, va? So in the case, what about acceleration? What about acceleration? Idhula vandu velocity constant alla we understood. Now tell me what about acceleration? Acceleration is actually constant da. Adoda value vandu positive da. Because ena again theta is actually acute angle da. So tan theta will become positive. Now tell me what about this C? What about this C? C. Yes, C la pathena again acceleration vandu constant da ana vandu idu vandu negative da. Why? This theta is actually more than 90 degree, so tan theta will be coming as negative, so we will be getting this. And what about D? What about D? Everybody tell me. So I'll go for the slope. Slope paakumbodhu idu vandu acceleration, slope increases, so acceleration increasing graph da. What about this one? Acceleration decreasing graph da. Okay, va? Everybody understood? Can you just give me a red velvet quickly in the chat box, everybody? If you understood. Yes, very good, very good, very good. Okay, so I wanted to know one more thing, the area under the velocity time graph. What is the area under the velocity time graph? What is that? It is nothing but displacement da. Okay, va? It is nothing but displacement. So if you wanted, you can just go for a screenshot quickly. I'm going for the next part. Okay, quicker. Session will finish around like 1:30. Okay, so one more is there. Nama acceleration da. Okay, nama acceleration time graph da. So idhula vanda we know that this is how a graph is coming now. What you will understand? Acceleration vanda constant da. Okay, va? And tell me what is the area under the acceleration time graph? Okay, what is the area under the acceleration time graph? Tell me quickly. What is the area under the acceleration time graph? It is nothing but clear note panniko, change in velocity. Velocity na adu vandu wrong answer. Change in velocity da vandu right answer. Purinjudha everybody? Can you just let me know in the chat box with a white forest, everybody? I'm waiting. Yes, very good, Jacob. Yes, very good, Ramya. Perfect. Don't say velocity, guys. That's wrong. Many times I have told you. So now let us go for the motion in a plane. Everybody is ready? Ready now? Put some fire if you are ready for the plane. If you are ready for the motion in a plane, quick call, let me know, guys. Perfect. Okay. So now we will be starting with the vector thing. So we know that, let us say if we have a vector like this. Okay, I have a vector like this. Xi plus Yj plus Zk. Okay, so then magnitude of A will be, how I'll be finding? Root of x square plus y square plus z square. Now I just wanted to find the unit vector of this one. So yeah, let us say if I'm talking about a vector A, actually வந்து அதுக்கு magnitude இருக்கும், அதுக்கு வந்து direction இருக்கும். அந்த direction தான் actually வந்து நம்ம unit vector. அப்படினா I could say that vector A divided by magnitude of the vector will be giving you the unit vector. In the case la vector வந்து xi cap plus yj cap plus zk cap da, divided by magnitude வந்து x square plus y square plus z square. Understood? Can you give me a red heart quickly, everybody? So இதுக்கு அப்புறம் பார்த்தேன்னா resolution of vector da. So இப்போ வந்து என்கிட்ட ஒரு vector இப்படி தான் இருக்கு. Okay, this is what vector A, which means இதோட magnitude வந்து A da. It is making an angle theta with the horizontal. Appadina, tell me what is the x component, what is the y component? Everybody, what is the x component, what is the y component? So, which is close to the side. So, idudha vandu namma x component will be a cos theta, and this is going to be our y component, a y will be a sin theta. Purinjadada? Everybody got it? So now let us say if I'm having a vector like this, okay, so it is actually making an angle theta with the vertical. Now, what will be the x and y components? Can you give me the x and y components, guys, quickly? X and y components. So this is going to be nama x component. Let us say b. Okay, so this will be bx will be b sin theta, and this component is going to be nama vertical component. By will be b cos theta. So depending upon the angle, this will be different. Purinjudada everybody? Are you guys getting it? Yes or no? Yes or no? Ipa right now I just wanted to find, okay, எனக்கு வந்து இருக்கிறது என்னன்னா magnitude of two vectors தான். Okay, என்கிட்ட இருக்கிறது magnitude of two vectors தான். அந்த two vectors குள்ள இருக்கிற angle கூட எனக்கு தெரியும். அப்படினா how I'll be finding the magnitude of the resultant. Okay, the magnitude of the resultant வந்து how I'll be finding. I will use triangle law, or let's say I will be going for parallelogram law. I will be getting a square plus b square 2ab cos theta, which means r will be nothing but a plus b. So in the same case, if I wanted to find a minus b, what will be the change coming? What will be the change coming if I wanted to find a minus b vector na in the equation la ellame same ah irukum, ana vandu inga vandu oru what is oru negative sign irukum. Purinjadada? Everybody getting it? Yes or no? Yes or no? Quick, let me know. So now next one pathena. Yes, very good Ashu, very good, very good. Adu vandu minus 2ab cos theta. Okay, that is the only change it will happen. Next one the direction da. Okay ba, if you wanted to find the direction of the resultant, I will go for taking the tan of that particular angle, which means it will be b sin theta divided by a plus b cos theta. Understood everybody? Can you give me a green forest quickly? Idukapram pathena we have one more thing, that is nothing but nama dot product and the cross product. So nama dot product pathena a dot b. Okay, you will be getting a scalar quantity. By multiplying two vector quantities, you are going to get a scalar quantity. Can you give me an example for it? Can you give me an example? So simple our example solitena nama work done na enna? Yes, force into displacement da. Force vandu oru vector quantity da, displacement vandu oru vector quantity da. So a dot b I will be get it as z. Got it? So this is what the thing. So if I mean you can just find it in two different ways. You can, if you know the magnitudes and the angle, you can just go for ab cos theta. Illa if you have this, let us say it is given in 2i cap plus 3j plus 4 cap, and the madri da if it is given na, you can go for ax bx plus ay by plus az bz. Okay, next one the nama cross product da. Okay, what will be the cross product? A cross b, two vectors multiplied, and we are going to get another vector. For example, torque. Okay, torque na r cross f, r in a position vector, f in a force, two vectors multiplied, and we got the another vector. So idoda result vanda a b sin theta n cap. Okay, n cap will be giving you the direction which will be perpendicular to. Okay, I can say that whatever be the the direction of A cross B, which will be same as the direction of C. A cross B சொல்லும்போது we will go for right hand thumb rule. How we will be doing it? We will just align our fingers in the direction of, okay, we will align our fingers in the direction of A, and then we will just curl our fingers towards the B. Then the thumb will give you the direction. So we will be going for right hand thumb rule for finding the resultant of this A cross B. Okay, direction find பண்றதுக்கு. If it is given again in terms of xi cap, I mean 2i cap plus 3j cap plus 4k cap, அப்படினா you will be finding the determinant. How you will be finding determinant? ijk, then ax, ay, az, then bx, by, bz. So you will be going for the determinant. If you want, you can just take the screenshot. We are going for the projectile motion. Everybody, and guys, you people are not liking the session. Done everybody. Can we go for the projectile motion? Yes, here is the complete formula. Okay, here is the complete formula. So first one, we know that whenever we are projecting something, okay, whenever we are projecting something, it will follow a projectile. Okay, it will follow a parabolic path. Okay, va? So idoda we are projecting with a velocity u, angle of projection vandu theta da. So definitely what we will be getting first, we will be getting the x component and the y component. Can you give me the x and y component quickly, everybody? And we know that in the projectile motion there will be only, okay, there will be only one acceleration is acting, which is nothing but g. And what is the direction of g? What is the direction of g? It is nothing but in the downward direction lada. So tell me, what will happen to the horizontal component of velocity all the time? Yes, very good, Fatima. This is coming as u cos theta and this is coming as u sin theta. My question is, what will happen to this ux element? Nama x component ku enna agum? When time goes, what will happen? That will remains the same everywhere nama velocity இந்த ஒரு பாயிண்ட்ல velocity x component of velocity பார்த்தேனா அது வந்து us இருக்கும். இந்த ஒரு பாயிண்ட்ல பார்த்தேனா this is going to be ux. இந்த ஒரு பாயிண்ட்ல again ux. இந்த ஒரு பாயிண்ட்ல again ux. So every pointல நம்ம x component of velocity will remains the same. What is the reason for it? What is the reason for it? The only reason is nothing but it is actually there is no acceleration in the horizontal direction. Adinala the velocity, the x component of velocity will remains constant. Very good, Fatima. Very good, Mohan. Everybody. So please give me a white forest quickly if you understood this ux part. Ux will be always constant. Yena there is no acceleration in that particular direction. What will happen to uy? What will happen to the y component of velocity? Tell me, everybody. Y component of velocity. It will decrease. Okay, it will decrease and it will come to 0 at the topmost point. Okay, at the topmost point what is vy? Okay, at the topmost point what is vy? Vy vandu 0 da. Adukapra what will happen da? It will increase and it is in the opposite direction. Correct alla? Opposite direction. It will come to 0. Adukapra in the opposite direction la nama vy oda value vandu, okay, inga vandu pathena it will reduce, here it is 0, inga vandu it will increase, inga vandu it will increase. So in the downward direction la it will increase. Got it da? So this is what is happening for vy. So now my question is, what is the net velocity at the topmost point? What is the net velocity at the topmost point? What is the net velocity in the topmost point, everybody? No issues, Ojal. You can just continue from here. Yes, Jacob. Very good, da. Very good, Fatima. It is coming as u cos theta. We have told you now. Okay, so in the point la ux will be there. What is the value of uy? Uy vandu 0 da. That is what we have written. Okay, so topmost point la, okay, topmost point la the net velocity is nothing but ux, which means u cos theta. Okay va? So adukapram you should know the projectile motion oda nama parabolic path oda equation da x tan theta minus gx square divided by 2u square cos square theta. Also you should study this representation as well. Same equation da, ana vandu we are writing in terms of nama range oda term la we are writing. Okay, so that expression vandu it will be x by r. Okay, நம்ம bracketல 1 minus x by r it will come. So you should study that as well. ஏனா வந்து sometimes they will they will give the range value. You need to find the y component. இல்லனா corresponding x ஓட y coordinate வந்து find பண்ணனும். So அந்த கேஸ்ல you should study this equation as well. Everybody understood? So now time of flight da, what is the equation for time of flight? 2u sin theta by g. What is the maximum height? U square sin square theta divided by g. What is the range? U square sin 2 theta by g. Illana you can say that x component of velocity into time of flight. Are you guys getting it? Can you just respond with a red velvet? Everybody please. Everybody. Yes guys, smash the like button guys. Why you hate this like button? அது ஒண்ணுமே பண்ணலல. Perfect. Yes. So அப்படினா we understood all of these things. Next வந்து நம்ம range ஓட few things தான். Okay, range will be maximum at what angle? Range will be maximum. It will be when theta is equal to 45 degree. So if theta is equal to 45 degree, what is the range? Maximum range வந்து what is going to be the value? It will become u square by g. Okay, it will become u square by g. Very good Fatima, it will be 45 தான். Okay வா? So அதுக்கப்புறம் பார்த்தேனா we are just projecting with the same angle, sorry, same initial velocity. Okay, but range will be same. What will be the other condition? Okay, initially we are projecting with the same initial velocity. Okay va, but different angles are, but we got again same range. What might be the reason? Yes, very good Jacob, very good Ramya, very good. Yes. No Kirti, think well. We are projecting with the same initial velocity but different angles tha we are getting the range. What might be the magic happening over there? Adukulla happening. Okay, maybe the velocity. What is the thing? The projected angles will be complementary angles are irukkalam, which means one angle is theta, other angle will be na move panna maata. Okay, so other angle will be 90 minus theta da, correct? So when we are just talking about same range na, same if it is same initial velocity, the range kadaikiradhukku ore oru chance da irukke, and the angle of projections should be complementary angles are irukkanum. Very good Ashika, very good Kirti, very good. Complementary angles are irukkanum. Okay, yes Fatima, complementary angles na enna? If one angle is theta, other angle should be 90 minus theta. Yes da Fatima, I missed it but I saw that. Okay, another important relation connecting nama r and h is nothing but r tan theta, which is equal to 4h. In the relation kuda you can just use it. Yena in the same question they have asked multiple times. Okay, what is the relation between r and h? So r tan theta will be coming as 4h. Adu vandu study panniko, note panniko. R tan theta which is equal to 4h. Understood everybody? Can you just give me a red velvet quickly in the chat box everybody? So now we are going for the horizontal projection. Horizontal projection la time of flight on the root of 2h by g da, and horizontal range vandu we know that inga vandu ux component. Okay, nama x component vandu specify பண்றது தேவையில்லை. ஏனா வந்து நம்ம horizontal projection na, okay, இது வந்து இந்த ஒரு பாயிண்ட்ல இருந்து தான் we are projecting. So in the x direction la தான் நம்ம initial velocity வர போறோம். So after that it will be, sorry, okay, it will be going like this. This is whatever we have mentioned h. So x component of velocity here, it is nothing but nama initial velocity da. So our range will be u into t, it will come, and also just before reaching the ground the velocity will be root of u square plus 2gh argum. Understood everybody? Yes or no? Are you guys getting what I'm saying? Please let me know. Yes, 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 yes. No, 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 anything. Okay, so next one the nama relative motion in 2 dimension da. So adula vandu first we will be handling the Lerin Mam problem da. Lerin Mam problem na, it is nothing but in which direction we should keep the umbrella. Okay va, so in that we always keep the umbrella in the direction of velocity of rain with respect to man. Just understand, எப்பவுமே இந்த umbrella வந்து we will be keep in the direction of VRM. What is VRM? Velocity of rain with respect to man. So we know that this is nothing but VR minus VM. So ipo vandu let us say rain is falling in a in a different angle. Okay, appadina you can just expand this VR. So what will become VR? So in the VR ku vandu x component irukkalam, y component irukkalam, correct? So appadina let us say I'm just telling. So rain is actually idha vandu rain is actually falling in this way. Okay va? So you know this angle theta. This is what the actual rain order direction. So அப்படினா definitely இதுக்கு வந்து x and y component இருக்கும். So VR will become, what is VR? VR will become VR sin theta I cap plus, sorry, not plus because இது வந்து minus j cap direction la da. So minus VR cos theta j cap it will come. So you can just replace this equation. Okay, you can just replace this equation as, okay, so VRM will be coming as what? VR sin theta I cap minus VR cos theta j cap minus velocity of the man. Okay, Vada. So velocity of the man, if you are taking in the direction of I, so you can just specify it as Vm I cap. Till this understood? Can you just give me a blue sky in the chat box, everybody? Till this understood, everybody? Okay. So the question will be coming as, let us say in the VRM is actually coming as, okay, the man is feeling like rain is falling vertically down, okay, which means VRM mode direction minus J cap. Appadina, what will happen? Can you please let me know what will happen? What I said, ipo question la they have specified it, okay, VRM is actually vertically downwards, vertically downwards, vertically downwards sollumbodhu, what is the meaning? What is the meaning? VRM is actually in the minus J cap, in the minus J cap. Appadina, in the I cap terms should be get cancelled. Okay, should be get cancelled. Appadina to get this two values cancel, we can say that VR sin theta should be equal to VM, then definitely it will be get cancelled. So if we need to keep the umbrella straight, okay, if the VRM should be exactly in the downward direction, definitely what must be the condition? VR sin theta should be equal to VM. Understood? Give me a yellow heart quickly, everybody. Everybody. Guys, give your like button and makeover by filling it with white paint. Oh my God. Super, 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 guys. Okay. Perfect, perfect. So, appadina we are going for the riverboat problem. Riverboat problem la first thing is like we have the downstream, we have the upstream. Can you tell me what is upstream and what is downstream? Upstream sollitena. Okay, let me just go for downstream first. Okay, downstream na the one who is moving. Okay, the swimmer arikalam, boat arikalam, whatever it may be, the boat and the river are flowing in the same direction. Downstream na both are in the same direction. So if someone is observing from the ground, what they will feel? Yes, in the two velocities are going in the same direction. So on the boat order, actual velocity vida adhigama it will feel. Correct? So appadina the velocity of the boat, okay, velocity of the boat will be VBR plus VR. What is VBR? Ipo on the boat, okay, if it is on the what is a still water la irukumbodhu, what is the speed, which means adoda actual speed da. Okay va, adoda actual speed da. VR na velocity of the river da. Okay, so when it comes to someone who is standing on the ground and they are observing the boat, so definitely avangalku vandu feel pannum enna idoda speed vandu it is more than the actual speed of the boat, ena vandu it is both moving in the same direction. Appadina, can you please let me know what is going to be in the upstream? Upstream na river is flowing in this direction and boat is going in the opposite direction. Appadina, அந்த கேஸ்ல upstreamல the velocity of the boat you will be feel like VBR minus VR. Understood, everybody? Can you please respond with your favorite emoji? Everybody, please quick up. What happened, Ojal? Guys, smash the like button. After June 21st, we cannot. Yes, exactly. So, now we are going for the river crossing problem. Okay, yena vanda river crossing problem that will become 2 dimension. Till whatever we studied in the river boat, it is actually 1 dimension da. Idoda 2 dimension da we are actually going to discuss. So, idhula vanda paathena this is what our river, idoda width vanda it is given D and velocity of river vanda it is mentioned it as VR. So, this is what the scenario. Okay, this is what the scenario. So, let us say in the still water, maybe you can just go in this way. Okay, Vada. In the still water, you can just go in this way. So, right now the thing is like, we wanted to find if you need to cross this river, what will be the time taken? Okay, what will be the time taken? Let us say I know this angle as theta. Okay, I know this angle as theta. So, right now my question is, what is going to be the time taken for it? Okay, so idhula vanda theta vanda they have taken the other one. Okay, they have taken this as the theta. Okay, adanalada it is coming as cos theta. So just depending upon the angle which is given, the question oda nama solution kuda it is going to be changed. Okay, so right now idudha vandu nama VMR na enna, velocity of man in the still water. Okay va, so appadina idukku vandu components irukum. One component will be VMR sin theta and another component is nothing but VMR cos theta. So now time will be the width of the river divided by and the direction la irukra velocity. So D divided by VMR cos theta it will come. Okay va, adukapram pathena we need to go for the zero drift, which means ipo vande I mean in the person is going this way, there will be some kind of displacement will happen, right? So and the displacement vandu vena. Okay, correct ah vandu the I mean if it is started from A, he should reach A dash. அப்படினா அதுக்கு இருக்கிற condition da sin theta should be VR divided by VMR. Okay, so adoda condition da VR, velocity of river divided by velocity of what is a man with respect to river. Okay va, understood everybody? Very simple arkenda, very simple, which means we need nama VM, actual velocity. Okay, yeah, நம்ம actual velocity வந்து vm வந்து இங்க இருக்கணும். அப்படினா what is the only thing possible? இங்க வந்து vmr sin theta இருக்குல்ல, so அது வந்து cancel ஆகணும். ஓகேவா, அது வந்து cancel ஆகணும். so இங்க வந்து then for that purpose the boat should, okay, the boat should go in this way, or the man should go in this way. So eventually what will happen, the velocity of what is a river irukke, so adanal it will just come to this line. Okay, vm will be coming like this. Appadina nama vmr sin theta will be coming in this direction. So vmr sin theta and vr should be get cancelled, then only we will get the net velocity. Someone is observing from the ground, avangalku vanda they should feel like the man is going literally along the width. அப்படி feel பண்ணனும்னா இந்த x components should be get cancelled. So அதுக்காக தான் we are doing இங்க வந்து boat தான் consider பண்ணிருக்கேன். So VBR sin theta should be equal to VR. Are you guys getting what I'm saying? Understood, Dora ma'am? Okay, thank you. Okay, I know that I'm just ignoring some of the comments. Don't think anything bad, because ஏனா வந்து minimum time we should finish this, அதனால தான். Okay, so next condition என்னன்னா minimum time taken. Okay, so இப்போ வந்து இந்த ஒரு I mean you can just choose any path, ஆனா வந்து minimum time you should cross the river na, what is the condition? அதோட condition தான் D divided by velocity of man with respect to river. So you should study all those things, ஏனா வந்து இதெல்லாமே வந்து important தான். Okay வா, done. If you are ready for the circular motion, go for some fire quickly. I need some fire. Or should we take a break, a very small break? A 10 minutes of break is needed. If you guys feel exhausted, I'll go for a break, because I actually வந்து நான் தான் வந்து exhausted இருக்கேன். Non stop பேசிருக்கேன்ல. 3 days more and we could understand, Dora ma'am, we are your veggies. Yes, exactly, Fatima. Ma'am, break. Okay, so let us just quickly go for a 10 minutes break. Adukapra circular motion வந்து continue பண்ணலாம். Okay வாடா. So now, okay, can we come by 11:42? Will be fine? Yes. Okay guys, so see you after this break. Hello, hello, hello. Am I audible? Are you guys here? Give me a fire quickly if you're ready for circular motion. Perfect, guys. Perfect. So let us continue. So let us continue with the circular motion. Okay. So we are going for it. So some circular motion la first வந்து instead of what is it linear displacement inga வந்து angular displacement da. So whatever we have written in the linear motion illiyada. So here I will be writing here. So Vz, theta, omega and alpha. So if you are differentiating this d theta by dt, you will be getting angular velocity. If you are going for d omega by dt, you will be getting alpha. So in the madri, if you are just integrating this, you will be getting the rest of the terms as well. So this is what the important thing. Next one enna nama linear and the angular terms or a connection da, which means v will be equal to r omega. Illena you can go for omega cross r. Okay, v is a vector quantity, omega is a vector quantity, r is a vector quantity. So v will be equal to omega cross r cap. What is the direction of omega da? It will be always perpendicular to the circular plane. Okay, circle வந்து xy plane lena in the omega oda direction வந்து it will be always perpendicular, which means z direction la irukum. புரிஞ்சுதாடா? So அந்த மாதிரி நம்ம tangential acceleration will be coming as r alpha. Tangential acceleration சொல்லும்போது let us say இப்போ வந்து இதுதான் வந்து நம்ம circular motion. Okay, இதுக்கு வந்து radius இருக்கு. Okay, this is what r value. So அப்படினா definitely there will be, okay, இப்போ வந்து change in magnitude ஆனதுனால, okay, magnitude வந்து change பண்றதுனால definitely there will be what to say acceleration, and due to, okay, and another one is nothing but nama centripetal acceleration. So two accelerations will be there. Okay, so one is due to this what to say this circular motion, and one is nothing but the change in direction. Okay, so adanala I will be having, okay, due to this velocity I will be having one here, and also centripetal acceleration will be always towards the center. So in the madri I will be having two such acceleration, and I will be getting the net acceleration over here. Appadina, a net acceleration, what is going to be the net acceleration? What is going to be the net acceleration? Everybody tell me, what is going to be the net acceleration? AT square plus AC square. Purinjadada? So we will be having two acceleration, and the two acceleration one the tangential as well as the centripetal acceleration da. So idhula vandu paathena nama net acceleration oda magnitude vandu root of AT square plus AC square da. AT sollumbodhu adu vandu r alpha da. Okay, also we can say dv by dt as well. Okay, wow. Tangential acceleration, you can just write it as dv by dt as well. AC will be coming as v square by r. Okay, AC will be coming as v square by r. 7 more likes, guys. Everybody. Okay, so next one, you can just substitute the values and you can just find this one, but you should know this equation, you should know tangential, you should know the centripetal as well. Okay, centripetal acceleration na v square by r da, tangential acceleration na r alpha da. If you understood, can you give me a yellow heart, everybody? Everybody give me a yellow heart, everybody. Quick. Sprinkle your love by liking the session. Oh my God. So yes, so right now we are going for the another part, which is nothing but centripetal acceleration kadachena. What is going to be centripetal force? Mass into that centripetal acceleration. What is Z as the centripetal acceleration? It is nothing but m into v square by r da. V one, if you want it, you can just write in terms of omega, then you will be getting m omega square r. Next one enna, let us say when we are just going on a level road, okay, when you are going in a level road, what is the maximum speed you can use? Adha vandu root of mu r g. Okay, mu na nothing but nama coefficient of friction da, r na vandu nama ipo vandu and the radius illada, that is what r, and g vandu nama acceleration due to gravity. So ipo vandu different ana cases, I hope you guys remember in the equation vandu it is important da. So now let us say இப்போ வந்து okay, you are just going for a turning. Okay, remember, I mean, just focus here da. So if you are just taking a turn, okay, if you are taking a turn, what actually happen in the ஒரு turning illa, okay, in the 5 more likes. Okay, Shamida, guys, everybody, okay. So right now in the ஒரு turning illa, if it is level road, there is no banking. Okay, there is no banking, only it is a level road na. We know that, we have seen that the velocity, the maximum velocity was mu rg. ஆனா வந்து இந்த equationல problem என்ன? இப்போ வந்து coefficient of friction வந்து very less. Let us say இப்போ வந்து what to say da, நம்ம after rain and all, it is actually kind of கொஞ்சம் டிஃபிகல்ட், அத வாக்கிங் கூட கொஞ்சம் டிஃபிகல்ட், அந்த மாதிரி தான் இருக்கு, ரொம்ப ஸ்மூத்தா இருக்கு. சோ கோஎஃபிஷியன்ட் ஆஃப் ஃபிரிக்ஷனோட வேல்யூ வந்து அவ்வளோ கம்மியா இருக்கு. சோ அந்த ஒரு டைம்ல யூ கான்ட் ஈவன் கோ வித் a very low speed as well. சோ இது வந்து what is it, இந்த ஒரு ப்ராப்ளம் சார்ட் பண்றதுக்கு தான் ஆக்சுவலா வந்து we introduce this banking of roads. Okay, so tell me what is banking of roads? Banking of roads na என்ன? It is nothing but we will, okay, level road na இப்படி இருக்கும். Banking of roads பாக்கும்போது இங்க வந்து ஸ்லைட்டா ஒரு, okay, it is slightly inclined இருக்கும், which means நம்ம ஹேர் பின் எல்லாமே பாக்கும்போது, okay, yes da, இப்போ வந்து நம்ம ஹேர் பின் எல்லாமே பாக்கும்போது you can see there, okay, so இப்படி தான், okay, it is actually having an inclined kind of, okay, so அங்க வந்து ஒரு theta angle வந்து inclined இருக்கும், which means it will be coming like this. Okay, நம்ம road வந்து இப்படி தான் இருக்கும், there will be a inclination with the horizontal which is coming as theta. புரிஞ்சுதாடா everybody? Guys, don't forget to like the session. Okay, so now இப்போ வந்து அந்த ஒரு கேஸ்ல friction எதுவும் இல்ல. Okay, friction எதுவும் இல்ல, only in the inclination மட்டும் தான் இருக்கு. அப்படினா you can go up to a speed which is nothing but root of rg tan theta. Root of rg tan theta. புரிஞ்சுதாடா? If there is no friction. If there is a friction, you can just go up to, okay, you can just see that if you are just going like this, okay, you are just going like this, definitely there are two chances. Okay, when there is a banking, there are two chances. Either you will be coming towards the center or you will move like this. If you are going with a very large speed, what will happen? You can't just turn properly, you will just go like this. You might have heard about a lot of accidents, correct? Accidents patti we have learned, I mean, we heard a lot from the newspaper. Actually வந்து what is happening, I mean, இந்த ஒரு velocity விட, okay, maximum velocity வந்து இந்த value தான், இத விட அதிகமா actually வந்து they are going. அப்படினா what will happen? The actually வந்து அந்த turning கிடைக்காத, they will go in the tangential velocity ஓட directionல it will move, which means நேரா அது வந்து it won't go for circular motion, it will go straight போகும்போது தான் one accident. Another one is nothing but in the minimum velocity விட even lesser velocity ல நீங்க வந்து you are going. Okay, even இத விட lesser ஆன velocity ல if you are going na, what will happen? You will just go towards the center. Okay, அது கூட it will create the accidents. Okay, so அப்படினா of course your speed should be in this range. Okay, in the minimum and maximum range ல தான் இருக்கணும் நம்ம speed when you are going in a banked road with a proper friction. Understood everybody? Can you give me a blue sky in the chat box? Everybody please let me know. Okay, என்னடா everybody is laughing, you people are not telling anything to me. Yes, perfect. So this is what the thing. Next வந்து என்னன்னா vertical circular motion, நம்ம giant wheel மாதிரி. Okay, நம்ம giant wheel மாதிரி. So அதுக்கான few conditions இருக்குடா, so just note பண்ணிக்கோ. First என்னன்னா, let us say you are going for a vertical circular motion, you just tied something, அதுக்கப்புறம் you are just doing whirling like this. Okay, இந்த ஒரு டைம்ல what will happen? So actually வந்து let us say if I am just going with a very low velocity, what will happen? Will it complete the rotation? Will it complete the circular motion? No. Correct alla? If I'm just doing like this, okay, I'm just giving a very little velocity, அப்படினா it will go, maybe it will go up to this, then it will come back. Correct allada? So actually வந்து ஒரு minimum velocity இருந்தா மட்டும்தான் it will complete. Okay, எனக்கு வந்து I have to give a minimum velocity, then definitely it will go for a circular motion. And the minimum velocity that should be at the at the lowest point is nothing but root of 5gl. okay, root of 5gl, which means இப்போ வந்து இந்த value இந்த ஒரு பாயிண்ட்ல நம்ம initial velocity வந்து lowest pointல velocity சொல்லும்போது நம்ம initial velocity தான், அந்த initial velocity is more than root of 5gl னா மட்டும்தான் இந்த circular motion will be completed, இந்த circular motion will be completed. So next வந்து பார்த்தேனா you can see here minimum velocity of the highest point. So definitely to complete the rotation or complete the circular motion, it is coming with root of 5gl velocity. When it reaches this point, again the velocity will reduce. ஏனா வந்து நம்ம acceleration due to gravity வந்து downward directionல தான் இருக்கு. So what will happen? So it will root 5gl reduces and it will come to a velocity at this point, highest point இல்ல. அந்த velocity is nothing but root of gl. Then this complete, okay, nama circular motion will happen. And the particular points illa in the lower point and higher point la irukra tension value kuda inga it is given. So you can, I mean, if you want it, I will suggest you people to by heart this. Ena vanda in the equations vanda derive panni adu vanda you have to apply, adu vanda time consuming da. So please, if possible, try to study this, okay? And இன்னும் one more important thing என்னன்னா, let us say instead of a string, okay, instead of a string we have a rod, okay va, instead of a string you have a rod right now. அப்படினா இந்த ஒரு கேஸ்ல, okay, instead of replacing the what is a string with something, I'm just replacing with a rod na, definitely it should also go for a circular motion, right? So அதுக்காக இந்த lowest point la what should be the velocity? That is again very simple, it should be greater than or equal to root of 4gl arkanu. Got it? Okay, what I said. So இப்போ வந்து instead of a string with a stone or something you just kept na, அதோட conditions தான் இங்க வந்து we have discussed. இப்போ வந்து I'm replacing with a rod, okay, அப்படினா tension இல்லங்க, okay, tension வந்து it won't be considered. So definitely to complete this circular motion, this should have an initial velocity that should be minimum root of 4gl arkadum. 2 more likes guys, you can just like the session quickly, everybody. So next one we are going for nama laws of motion, okay? Laws of motion la first law, what is the first law? Simple as solitana, if there is no external force acting on it, okay, if nobody is pressurizing you to study, what you will do? You will either sleep or you will just scroll. Correct ada? Yes or no? Can you please let me know? இப்போ வந்து யாருமே force பண்றதுக்கு இல்ல, அம்மா இல்ல, teachers இல்ல, யாருமே இல்ல அப்படினா either you will sleep or you will scroll. அப்படினா I could say that if there is no external force acting on the what is a body, definitely it will continue at rest, okay, sleeping. இல்லனா uniform motion என்னடா அது? Scrolling. Okay, so that is what the Newton's first law. Correct ah? Aama enakku theriyumda. Okay, first law vanda, if there is no external force acting on the body, every body will continue its state of rest or its uniform motion. Okay, so that is what the first law. What is second law? Second law is very simple. The force is nothing but the rate of change of நம்ம target achieve ஆச்சுடா. Okay, the rate of change of momentum dp by dt தான் actually வந்து நம்ம force. So I can just say that இங்க வந்து I'm applying the product rule, which means m into dv by dt plus v into dm by dt. So usually whatever we were discussing, adala vanda mass vanda it is constant da, appadina dm by dt will become 0. We will be getting the force as m into a, mass into acceleration. Understood? Can you give me a black heart everybody? So that is what the thing. Next one என்னன்னா நம்ம what is Newton's third law da. Third law is nothing but for every action there is an equal and opposite reaction. So right now unga sibling வந்து அங்க what is it தனியா he or she is not doing anything, okay, not even irritated, but you are just going, summa you are going and you are just doing this. What will happen? Equal and opposite reaction on the same instant la, without even a fraction of second difference la, you will get the reaction illada. So that is what the Newton's third law. Okay, if you are giving an action you will get the reaction. So now my question is, action happened on your sibling and reaction happened on everybody. Tell me, what is the reaction? Reaction happened on you. Correct alla? Action you did with your brother or sister, whoever it may be, okay? Ana vanda reaction was happened on you, which means action and reaction is happening in two different bodies. Got it? No siblings, okay? So just fight with me, Rashamida, okay? So right now, this is the thing. when there is an action reaction happening which is actually happening in two different bodies da, it will never cancel each other. Okay, it will never cancel each other. Ena vandu two different bodies la happen, right? Okay, it will never cancel each other. We know that if your sibling has given one to you, you will give one, again two. So idu vandu continue pannumla. So and madri da. So it will be never ever it is going to cancel. Okay, it is not going to stop when it comes to your fight. Okay, so this is what the thing. Now we have the linear momentum. Linear momentum na, it is actually the ability, or let's say I could say that it is actually the what I forgot da. It is actually the amount of motion da. Okay, wow. So if the momentum is more, it is going to be very difficult to stop the motion. Okay, wow. That is what the idea about the linear motion. So sorry, linear momentum. Linear momentum vandu vector illa scalar ada. Linear momentum vandu of course it is a vector quantity da. So next vandu paathena, I just wanted to talk about the conservation of linear momentum. Okay, what is conservation of linear momentum? If there is no external force acting on it, dp by dt will become 0. Appadina dp will be 0. Appadina initial momentum will be equal to final momentum, and I will be getting the momentum will be constant. Purinjada everybody? Can you give me a white forest in the chat box quickly? Okay, so ipa vandu initial momentum is constant. Okay, initial momentum which is equal to final momentum na. Okay, I could say that m1 u1 plus m2 u2 which is equal to m1 v1 plus m2 v2. Okay, got it? Yes, so this is what the thing. Next one, the impulse. The impulse is nothing but a force which is acting for a very short time. Okay, a large force acting for a very small time. So that expression one, it is nothing but integral f dot dt, which is nothing but change in momentum. So if I am plotting, okay, if I am plotting force and the time, okay, wow, force and the time. So now I am getting a graph like this. Okay, wow, I'm getting a graph like this. What is the area under this force time graph? What is the area under the force time graph? Can you please let me know? Can you please let me know? What is the area under the force time graph? It is nothing but nama impulse illana, we can say change in momentum. Okay, it will be, hey, adu vandu displacement ida, idu vandu time illa. Force and displacement varumbodhu da work done. Okay, why you people are saying work done? Idu vandu force and time illa, not displacement. Yes, very good Ashika, impulse. Yes, very good Jia, impulse da. Okay, va, impulse illana, we can say that change in momentum. So just note panikoda, area under the force time graph will be change in momentum. Illana, it is going to be nothing but nama what is a impulse. Understood? Okay, this is what the impulse momentum theory. The change in momentum will be equal to impulse. Understood? Can you give me a blue sky in the chat box, guys? Everybody, I wanted to get everyone's response. So now we are going for the equilibrium. Okay, equilibrium சொல்லும்போது we know that when F is equal to 0, we will say and the body under equilibrium. The net force is equal to 0, representing that it is nothing but equilibrium. So இப்போ வந்து இந்த equilibrium சொல்லும்போது I have two types of equilibrium. Even in the linear or translational equilibrium சொல்லும்போது அதுல வந்து two categories இருக்கு. Static equilibrium and dynamic equilibrium. Can you please let me know what is that? Can you please let me know what is that static and dynamic? So let us say net force, static சொல்லும்போது இல்லனா dynamic சொல்லும்போது actually வந்து both caseல net force வந்து 0 தான். ஆனா வந்து maybe one caseல, okay, first caseல வந்து net force 0 தான், object வந்து restல தான். And second caseல வந்து net force 0 தான், ஆனா வந்து it is moving in the uniform motion. அந்த caseல கூட uniform motion நாலும் acceleration வந்து 0 இல்ல. So definitely we can say that either it will be at rest or otherwise I could say it is in uniform motion. அப்படினா what will happen da? First case net force 0, rest. அதுதான் வந்து நம்ம static equilibrium. Okay va? And second case net force is 0 but it is actually moving, but velocity வந்து constant தான். அப்படினா I will say that is actually dynamic equilibrium. Understood everybody? Please let me know through a blue sky, guys, everybody. So adukapram paathena nama questions la maybe you will be getting 3 concurrent forces. Concurrent forces na enna? It is actually acting at the same point. Concurrent forces na it is actually acting at the same points da. And the concurrent forces varumbodhu we could say that F1 by sin alpha which is equal to F1 by sin beta which is equal to F3 divided by sin gamma. I will just tell you. Okay, so this is how the forces. Okay, this is how the forces. Let us say this is F1, this is F2, this is coming as F3. So in the F1 oda opposite irukra angle da alpha. Okay va? F2 oda opposite irukra angle da beta. F3 oda opposite irukkiradhu da gamma. So I can just say that F1 by sin alpha will be equal to F2 by sin beta which is equal to F3 by sin gamma. Okay va? So இது வந்து common forces da. So actually வந்து when we are just going for in the laws of motion chapter la free body diagram வந்து அவ்ளோ important. So இந்த free body diagraத்துல பாத்தேனா அங்க வந்து common forces இருக்கு. Okay va? Common forces சொல்லும்போது அங்க வந்து weight இருக்கும், normal reaction இருக்கும், tension இருக்கும், spring force இருக்கும், pseudo force இருக்கும். So I think all these forces were familiar to you people. So pseudo force மட்டும் I will tell you da. Pseudo force na அது வந்து real force இல்ல. Okay, அது வந்து real force இல்ல. So actually வந்து சொல்லிட்டேனா pseudo force will come into play. Okay, இந்த pseudo force பத்தி we will talk when the நம்ம இப்போ வந்து அந்த observer is actually on in a non-inertial frame. Okay, இப்போ வந்து we have two frames of reference, inertial and the non-inertial frame of reference. Tell me what is inertial and what is non-inertial. Inertial சொல்லிட்டேனா அங்க வந்து acceleration of the frame of reference வந்து what is the answer? 0 தான். What is non-inertial frame of reference? அங்க வந்து acceleration 0 இல்ல. Okay, non-inertial frame of reference la acceleration 0 illa. Ipo vandu if the observer is on the inertial frame of reference which means acceleration 0 irukra frame of reference la irundha in the observer is watching everything. அப்படினா very good. Okay, அப்படினா we can say that அங்க வந்து pseudo force consider பண்ணாத. But when it comes to non-inertial frame of reference, which means accelerating frame of reference, definitely what will happen da? அங்க வந்து pseudo force consider பண்ணனும். ஏனா அந்த frame of reference ல Newton's law வந்து valid அல்ல. அது வந்து valid ஆகிறதுக்கு தான் இந்த pseudo force வந்து we are introducing. So pseudo force வந்து how we will be finding the pseudo force? Simple இருக்கே. Pseudo force வந்து m into a தான். M na அந்த object இல்லையாடா where we are finding the force அந்த object ஓட mass தான். A na என்னடா acceleration of our non-inertial frame of reference. Okay, acceleration of non-inertial frame of reference அதுதான் வந்து pseudo force. And எப்பவுமே இது வந்து negative. Okay, I will just mention pseudo force is equal to minus a accelerating frame of reference. Why so? ஏனா வந்து இந்த pseudo force will be always act in the opposite direction of accelerating frame of reference. புரிஞ்சுதாடா? எப்பவுமே இப்ப வந்து நம்ம frame of reference is going like this na pseudo force will be acting downwards. Okay, acceleration of frame of reference is upwards but definitely pseudo force will be acting downwards. Understood? Can you give me a red velvet quickly everybody? So this is what the pseudo force. Very good Ashika. It will be act in the opposite direction of acceleration of the frame of reference. Next on the motion of connected bodies da. So idhula vandu first vandu we will talk about lift la irukke. Okay, we are actually at the lift. Okay, so lift vandu it is going up, going down, and the time la what is the velocity what is the weight we will experience, the apparent weight. So don't be get confused da. Apparent weight na it is nothing but the normal reaction force da. Okay va? Apparent weight na the weight we feel அது வந்து actually equal to normal reaction force da. So first case பார்க்கலாம்டா. இந்த lift is moving upward with an acceleration. Okay, so இங்க வந்து lift இருக்கு. So இங்க தான் நம்ம object இருக்கு. So obviously mg will be acting downwards. Normal reaction will be acting upwards. And we know that the acceleration is happening like this. Okay va? Acceleration is happening this way. So now you know that in the I'm just observing this object from an accelerated frame of reference. அப்படினா நம்ம pseudo force ஓட direction எப்படி இருக்குடா? Pseudo force ஓட direction upward இல்ல downward? Pseudo force ஓட direction everybody pseudo-force oda direction. Guys, don't forget to like the session da. Pseudo-force oda direction வந்து accelerating upward இல்லடா. நம்ம frame of reference is accelerating upwards. So definitely it will be in the downward direction. So இப்போ வந்து இந்த body பார்த்தேனா mg is acting, also n is acting, ma also, we can just write it like this. அப்படினா I could say that this body is not moving. If I am observing from the accelerated frame of reference na, in the body is at rest la da. So I could say that n will be equal to mg plus ma. This is what our first case. Okay vada. Next one, it is going downwards. Okay, it is going downwards na. What will happen? If it is going downwards with an acceleration, what will be the direction of pseudo force? What will be the direction of pseudo force? It will be going upwards da. So this is what will happen. So I can say that n plus ma, which is equal to mg. So அப்படினா n தான் நம்ம apparent weight. அப்படினா what will happen da? mg minus ma it will come. So I'll be getting like this. If it is not an accelerating frame of reference, okay, so இப்படி தான் நம்ம lift இருக்கு. Okay, so இங்க வந்து mg இருக்கும், இங்க வந்து n இருக்கும். Okay, acceleration இல்லனா frame of reference is not accelerating na, pseudo force இருக்காது. அப்படினா what is the apparent weight what you are going to experience? It is going to be n is equal to mg மட்டும்தான். Okay va? Now the thing is like it is going down, okay, with acceleration due to gravity. Right now nama frame of reference is under free fall. Okay, it is going with a what is acceleration which is equal to g. Then what will happen da? Then what will happen? We know that, yeah, I mean this mg da, it is going to act upwards. Mg will be downward as well. So n plus mg, which is equal to mg. So I can say that n will be coming as 0. So you will feel weightlessness. Understood, guys? Can you just give me a black heart, everybody? Everybody? Give me a black heart quickly. Okay, set, all set. Like the session, guys. Ojal is on the what is it, Chandramukhi mode on, I guess so. Okay, so right now we are going for the Atwood machine. Okay, I'm just removing this. If you want, you can just take a screenshot. I wanted to draw the another diagram. If you want, you can just take the screenshot. Okay, yes. So right now we are going for the Atwood's machine da. So adula vandu paathena okay, so ipdi da irukke. Okay, so here is the thing. So this is what our M1, this is what our M2. So what will basically happen da? What basically happen? So M1 is more than M2 na, the acceleration will be in this direction and here it will be experiencing an acceleration in this way. Okay va? So now I can say that inga vandu M1G irukke, inga vandu M2G irukke. In the madri questions kadachena, what we should do? After marking all the forces, we can just keep it in a straight line, in a horizontal direction. So அப்படினா இங்க வந்து M2 இருக்கும், இங்க வந்து M1 இருக்கும், and when I'm just keeping this over there, M1G will be in this direction, and inga vandu if I'm just keeping like this, I will be getting M2G in this direction, acceleration in this way. Okay, I hope everybody is confident about this method. Okay, illanalum paravalla, you can just find the what to say in the M1 la experience pandra forces, M2 la experience pandra forces use panni you can just find it. Adula edu problem illa, but I'm just telling you idudha vandu easy ah correct ah we will get the answers. Okay va? So இப்போ வந்து acceleration find பண்ணனும்னா அதுக்கு வந்து சிம்பிளா ஒரு equation இருக்கு, driving force divided by m1 plus m2, which means the net force experiencing on this object. Okay, so இங்க வந்து பார்த்தேனா what is going to be the net force da? m1g minus m2g. ஏனா வந்து two forces acting exactly in the opposite direction da. So அப்படினா m1g minus m2g, that is what the driving force, divided by total mass will give you the acceleration. And the tension, if you wanted to find it, which is going to be 2m1 m2g divided by m1 plus m2. So you have to study this as well. Okay, wow. Everybody understood? Can you please let me know? Everybody. So now we are going for the friction. Okay, wow. So friction la we know that we have 2-3 types of frictions. First one is static friction, second one is kinetic friction, third one is nothing but rolling friction. So idhula the value will be high for static friction, then kinetic friction, then the rolling friction. Yena the coefficient of friction will be high for the static friction, adha vida kammiya irukkum namma what is it namma kinetic friction, adha vida kammiya da irukkum rolling friction. So and the rolling friction and the coefficient of rolling friction kammiyanadunala mattum actually we have introduced this trolleys, because without pushing, okay, without applying much force, it will move. The frictional force which is coming against will be less compared in the rolling friction. So அப்படினா static friction la start பண்ணலாம். Static friction அது ஒரு self adjusting force தான். So which means if you are giving 5 Newton, it will give 5 Newton. If you are giving 6 Newton, it will also give 6 Newton. If you are giving 10 Newton, it will also give 10 Newton. ஆனா when two surfaces are in contact, இந்த two surfaces குள்ள apply பண்ற இல்லனா இந்த surface க்கு what is it oh எனக்கு the word கிடைக்கல. Okay, the friction which it can be given, okay, the friction can given by these two surfaces will be nothing but what is it, the maximum friction oda value da நம்ம limiting friction. When two surfaces are in contact, the maximum friction which can exert is called as the limiting friction, or I can say that the maximum value of static friction will be limiting friction. So when I'm talking about 5 Newton, 5 Newton, 6 Newton, 6 Newton, 7 Newton, 7 Newton, ஆனா let us say in the two surfaces, when these two surfaces are coming in contact, இதுக்கு maximum provide பண்ண முடியும் அந்த static friction oda value let us say 15 Newton da. So let us say I'm just asking you 10 Newton apply பண்ணிட்டேனா, even it can provide 15 Newton nalum, it will give only 10 Newton. Okay, I have told you enkitta 15 apples irukku, you are asking only 10, I will give you only 10. If you are asking me 12, I will give 12. If you are asking me 14, I will give 14. But if you are asking me 20, I can give only 15. Understood, Ada? Everybody getting it? Yes or no? Can you please let me know? So whenever we are talking about static friction, adu self-adjusting force da till the limiting friction. Limiting friction na it is actually the maximum amount of friction da, and in the limiting friction oda value da mu into n da in the limiting friction oda value. When it comes to kinetic friction, when we will talk about kinetic friction, when it started moving and the time we will say it is actually the kinetic friction. So when it comes to the kinetic friction, when it is about to start sliding, when it is about to start the motion, and the time la irukkiradhu da kinetic friction. So kinetic friction oda value will be coming as mu k into n. Mu k na enna? Kinetic friction oda coefficient da. So I can say that mu k will be definitely lesser than that of the static coefficient of static friction. Next on the angle of friction da. Angle of friction சொல்லும்போது let us say when two surfaces are in contact, okay, இங்க in the irregularities நால there will be some small intermolecular forces will be there. இதோட resultant தான் நம்ம contact force. Okay, இதோட resultant தான் நம்ம contact force. So இந்த contact forceக்கு parallel component இருக்கு, perpendicular component இருக்கு. என்னடா இந்த parallel component னா it is nothing but நம்ம frictional force தான். இந்த perpendicular component னா it is nothing but நம்ம normal reaction force தான். Understood everybody? So அப்படினா this angle இல்லையாடா, இந்த contact force and the normal, அந்த angle da actually angle of friction. அப்படினா tell me in the case what is tan theta? What is tan theta? Tell me everybody. What is going to be tan theta? Tan theta is nothing but f by n it will come. F by n na enna? Coefficient of friction. Got it everybody? Can you guys give me a white heart if you understood? Everybody? So this is what the tan theta. Next on this angle of repose da. Angle of repose சொல்லும்போது let us say இப்போ what is it in the horizontal surface da. Okay va, I just kept something on the horizontal surface. Now I'm just increasing, okay, I'm just increasing the angle, I'm just keeping something, okay, I'm just increasing the angle of inclination. Okay, so at some point what will happen? Definitely in the body will start move. Okay, so அந்த ஒரு particular angle of inclination the angle of repose. When it comes to the equation, நம்ம angle of friction and angle of repose ஓட equation mathematical representation வந்து same தான். Okay, mathematical representation வந்து same தான், but ஆனா வந்து the concept is different. Angle of friction னா இதுதான், angle of repose னா என்ன? It is an angle of inclination at which the body tends to move. That is what the angle of friction. Understood, guys? Yes or no? Can you please let me know, guys? Everybody, can you please let me know through your favorite heart? Yes, Aditi. 38 more people. Don't forget to like the session. Okay, perfect. Okay, so now friction முடிஞ்சிருக்கு. Now we are going for the rocket propulsion. This is again coming as another thing which is based on nama what is a second law. Second law la we said that F is equal to d by dt of mv da. So after applying the product rule, I will be getting m into dv by dt plus v into dm by dt. So in the mass vary பண்ணும்போது in the force order equation will be changed as v into dm by dt. So இதோட application தான் நம்ம rocket propulsion ல இருக்கு. Rocket propulsion ல என்னடா it is happening, the exhaust velocity இருக்கு. Okay, actually வந்து the fuel will burn and the mass will reduce and அந்த mass reduce இல்லனா அந்த mass vary பண்றதுனால தான் actually வந்து yes okay. Yes, nama இன்னைக்கு evening actually வந்து கோபிகா மேம் 4 or 5 மேம். Okay, session timing கூட தெரியல மேம். Okay, so actually வந்து இந்த செஷனுக்கு அப்புறம் ஈவினிங்ல we have 600 plus செஷனோட I mean 600 plus guarantee பண்ற ஒரு செஷன் இருக்கு. So அந்த செஷன் வந்து everyone should join. Okay வா? So இப்போயே I mean right now itself you can just go and you can just check that. எங்கடா இருக்கு? Okay, so where is it? So nama live sessions la you can see here engada irukke, yeah, here is the session. So 4 pm kuda, so you can just 4 okay, so 4 pm we will decide. Okay, so 4 pm la edacha some changes irukunda, ena vandu we are planning something more. Okay va, so adoda updates vandu we will give. Okay, so koncham interesting ana what to say shorts ellam vandu it is going to come, so wait, because I know that ninga students vandu you people are more waiting for nama shorts ku da actually vandu you people are waiting. So and the shorts vandu koncham planning pandrom, so adukapra we will again start the session. So 4:35 varaikku இந்த session vandu delay ஆகிறதுக்கு chance இருக்குடா, but definitely we will let you know. So மறக்காம இப்பவே vandu you can just like the session. Okay, so ingada like button, you can just like the session ippave vandu you can just like. Everybody ready? Okay, so now again back to nama physics la da. Okay, so right now we know that nama rocket propulsion சொல்லும்போது என்னடா rocket propulsion சொல்லும்போது என்ன so nama mass will be, okay, the fuel burn ஆகும்போது நம்ம mass will reduce and அந்த mass reduce ஆனா definitely அங்க வந்து acceleration, so இல்லனா அங்க வந்து ஒரு thrust force இருக்கும், அந்த thrust force use பண்ணி தான் actually வந்து rocket is going upwards. So அந்த ஒரு டைம்ல the force will be coming as the relative velocity. Okay, relative velocity வரும்போது நம்ம exhaust velocity தான், which is with respect to rocket. Don't think like it is with respect to ground. With respect to rocket, the exhaust velocity you have to find into the varying mass dm by dt pannitena you will get the thrust force. Understood everybody? Can you give me a green forest quickly in the chat box if you understood? I don't know, I'm only talking no adnala konjam exhausted ah feel pannirken after this exhaust velocity. So yes, now we are going for work. Okay, work da ma'am, எப்பவுமே hard work ma'am. Guys, மறக்காம like கூட பண்ணலாம்டா, and the like button is not going to do anything if you touch it. Okay, so now we are talking about work. So work na, what is work? We know that if it is a constant force, it will be F dot D. If it is not a constant force, what it will be? It will become integral F dot D. Okay, d சொல்லும்போது I can just go for dx. dx na the small displacement da when the force is not constant. So this is what the work done. And also let us say if I'm just going for, okay, if I'm just going for, before that you have already given the answer for another question, that was wrong, but right now I'm asking you, இப்போ வந்து எனக்கு கிடைச்சது இந்த ஒரு graph தான். What is going to be the area under the force displacement graph? Tell me what is the, oh my god, looking so beautiful da. Okay, so now tell me what is the area under the force displacement graph? It is nothing but the work done. The area under the force displacement graph will be coming as the work done. Understood everybody? Please let me know, guys. Everybody. Okay, so idukapram pathena nama kinetic energy da. So tell me the equation for kinetic energy da, everybody. Kinetic energy வந்து half mv square da. Also we can go for p square by 2m. So this is what the another equation for the kinetic energy. And also next one the important ஆன ஒரு concept from this work energy power chapter la irundhu, it is nothing but நம்ம work energy theorem da. What is work energy theorem? The work done by all forces which is equal to change in kinetic energy. Work done by all forces சொல்லும்போது அங்க வந்து conservative force இருக்கும், non conservative forces இருக்கும், external forces இருக்கும். So now I'm going for the modified work energy theorem. What is modified work energy theorem? இப்போ வந்து I wanted to know only for the conservative force. Okay, I wanted to find it only for the conservative force. Now this will be straightly coming as change in potential energy. Work done by conservative forces stored as work done against the conservative forces stored as the potential energy. So right now work done by non-conservative force will be coming as change in kinetic energy plus change in potential energy. This is what the modified work energy theorem, which is very important. Now tell me what is gravitational potential energy or equation? Gravitational potential energy or equation the mgh. What is elastic potential energy? Half into k into x square. So tell me what is the spring force, everybody? What is the spring force? Spring force in a F is equal to minus kx. Why that minus sign, guys? Why that minus sign? When we are talking about spring force, now let us say when we stretch a spring, or let us say when we when we compress a spring, what will basically happen? There will be a restoring force developed. So when I'm stretching, what will happen? When I'm just releasing it, immediately it will come to the original position, which means when I'm extending and the applied force or equal amount or restoring force will be developed in the spring in the opposite direction. So when I am just stretching, force or direction inside, correct? So displacement is outside and the force is coming inside, so I'll be get that minus sign. Very good, Fatima. Opposite direction la da irukke. So that is why the negative sign we are representing over the purinjadada. So another important thing which is nothing but nama energy conservation. What is energy conservation? Tell me, everybody. Energy conservation, it is nothing but if there is only conservative forces, okay, condition irukku, only anga vanda conservative forces mattum da irukke, okay va, conservative forces da mattum da irukke. Appadina the initial energy na kinetic energy plus potential energy will be equal to final, will be equal to not plus, okay. Ki plus ui, which is equal to kf plus uf. This is what the energy conservation. What is the condition da? What is the condition? Condition is nothing but if there is only conservative forces now you can go for that. Understood. Next on the important concept which is nothing but we know that F is equal to minus du by dr da. Okay va? So now if I'm talking about equilibrium, what you understood about equilibrium na nama net force will be 0 da. So appadina in the equilibrium I have few categories: stable, okay, I have stable, unstable as well as the neutral. So give me the conditions, guys, give me the condition. So stable சொல்லும்போது net force வந்து 0. In all three cases net force வந்து 0 தான். Also net force 0 na, force is equal to minus du by dr illa, so that is also going to be 0. Okay, then how I'll be identify this is stable, this is unstable, this is neutral? Very simple, we should go for the second derivative. Okay, second derivative. If it is positive, stable. If it is negative, unstable. If it is equal to 0, neutral. Understood, guys, everybody? So this is again very, very important relation that everyone should study from this chapter. Got it? Okay, so now the last topic, which is nothing but nama power ida. Power sollumbodhu we know that work done by time, or let's say we can just go for force into velocity. Okay, power vandu or scalar quantity da, force vandu or what is a vector quantity, velocity is again a vector quantity. If you want, you can just take a screenshot, and we are going to the next part, which is nothing but collisions. If you're ready for collision, put some fire quickly. Perfect, perfect. Guys, you people are not liking the sessions, guys. Like the session. Okay, perfect, perfect. So now let us go for the collision. Okay, so if on the collision da irukku, collision la first you should know the coefficient of restitution. What is coefficient of restitution? It is nothing but the relative velocity of separation divided by velocity of approach, which means v2 minus v1 divided by u1 minus u2. Okay, va? And for a perfectly elastic collision, this E value will become 1. And for a perfectly inelastic collision, this E value will be in between 0 to 1. Perfectly inelastic collision, na, E value will be coming as approximately 0. Okay, va? So let us just understand perfectly elastic collision. Na, adula vandu we know that the kinetic energy will be conserved. I mean, like the kinetic energy will be conserved, total momentum will be conserved. Correct? If you like Dora, I'm like the session. Note after that I will be get disappointed, Ramya. Okay. Chat box looks like volcano. Okay. Yeah, exactly. Yes. Okay. So right now, Paravalada, like on the secondary right now. Let us just focus here. We can just finish as soon as possible. Okay, we are at after 2 hours we have, this is the 5th chapter, right? Work, energy, power, 5th chapter lada. Correct? Units and measurements, straight line, plane, laws of motion, 5th chapter. Innum chapters irukku. Okay, va? I really don't want to go for any part 2 for this. Okay. ஏன்னா வந்து பார்ட் 2க்கு நல்ல டைம் இருக்கா எனக்கு தெரியல. ஓகே, லெட் மீ see. ஓகே, சோ இப்போ வந்து பார்த்தேன்னா நம்ம பெர்ஃபெக்ட்லி எலாஸ்டிக் கொலிஷனோட tell me அதுல வந்து மொமெண்டம் கன்சர்வ்டா இருக்கும், கைனெட்டிக் எனர்ஜி கன்சர்வ்டா இருக்கும். Loss in kinetic energy will be Tell me, it will be coming as 0 in the perfectly elastic collision. In elastic collision சொல்லும்போது it will be momentum conserved இருக்கும், ஆனா வந்து kinetic energy conserved அல்ல. There will be a loss in the kinetic energy. So now I am going for the one dimensional elastic collision. அதுல வந்து after collision the two objects ஓட velocity v1 and v2 is here. So you can just by heart this equation. ஏன்னா வந்து அந்த டைம்ல exam டைம்ல derive பண்ணி study பண்றதுக்கு it is going to be very difficult. Time we don't have. ஏன்னா வந்து இந்த even if you got this equation நாலும் இந்த calculation இருக்கேலடா, so it is going to be very difficult. So please study this equation. Also நம்ம inelastic collisionல இருக்கிற நம்ம what to say நம்ம change in kinetic energy, or let's say the loss in kinetic energy, final kinetic energy minus initial kinetic energy, அதோட equation கூட you can just by heart da. ஏன்னா இது வந்து அவ்ளோ important. yes da Ojal Fatima, yes Shamida, ஆமா Shamida got a what is a little hen also. Okay, so this is what you have to study. Don't forget. And also in the along with this you should study the common velocity after the perfect inelastic collision. Okay, I will write it over here. Perfect inelastic collision. Perfect inelastic collision சொல்லும்போது என்னடா actually வந்து let us say when we throw something. Okay, let us say we will throw some mud on the wall and we will just place the plants, right? Okay, in some of the places I have seen that. Okay, so actually what we are doing, we will take some mud and we will just go, we will just throw there. right? So adukapram pathena what will happen, nama wall and that mud is having the same velocity, will be 0. So and the madri two bodies are coming, adukapram what is happening, it will go with a common velocity. Appadina what will happen da, conserve momentum conserved alla. So I can say that m1u1 plus m2u2 will be coming as m1 plus m2 into the velocity. Appadina the velocity v value will become m1u1 plus m2u2 divided by m1 plus m2 will be coming as u. Will be coming as not u, it is actually v. Okay, the after perfect inelastic collision, the common velocity will be yes, exactly. Okay, chicken kuttiya. Okay, so this is what the common velocity. Done. Nama work energy chapter is also done da. Everybody, if you are ready for nama center of mass, please put some fire quickly. Everybody. Perfect. Okay, so now let us just quickly go for the center of mass. Okay, so in the center of mass first one the position of center of mass da, adukkaga we will be going for if there is discrete particle na enada, actually inga oru particle irukku like point masses da, m1 irukku, m2 irukku, m3 irukku, m4 irukku. So in the one case if you wanted to find the moment moment of inertia, center of mass, okay, so what you will do, you will just consider a a reference point. Okay, so let me say இப்போ வந்து இங்க தான் m1 இருக்கு, இங்க தான் m2 இருக்கு, and the distance of separation between them is d. அப்படினா I'm just asking you what is the center of mass oda position. So nothing else is given, this is what the data, m1 இருக்கு, m2 இருக்கு, distance of separation வந்து d தான். So now what you will do, you will just keep the reference point as m1. Okay, so appadina m1 oda coordinate enada, x and y coordinate, it will become 0 0. Okay, it will become 0 0. And what will be the coordinate of m2? Tell me quickly. M2 oda coordinate vanda, it is nothing but x coordinate will be d, y coordinate will be 0. So inga vandu paathena we just need x is OM. Okay, wow. How you will be finding x is OM? You will be find it as m1 x1 plus m2 x2 divided by m1 plus m2. So m1, okay, m1 I will be put it as m1. What is x? What is x1? Tell me everybody, what is x1? Hey guys, I want your response guys, please. What is x1? Adu vandu 0 da plus m2 into what is x2 guys? What is x2? Adu vandu d da divided by m1 plus m2. So இப்படி தான் we will be finding the center of mass oda position. Okay, so இப்போ வந்து we understood this. Next வந்து இப்போ வந்து discrete particle இல்ல, continuous body தான், which means இந்த மாதிரி ஒரு road இருக்கு, இல்லனா ஒரு sphere இருக்கு. So அதோட center of mass find பண்ணனும்னா you should use this equation. Okay, RCOM will be 1 by m integral RDM. So you should study this equation as well. Everybody got it? Yes or no? Another thing என்னன்னா let us say இப்போ வந்து initially எனக்கு வந்து ஒரு object இருந்துருச்சு. Okay, maybe let us say I had a disk. Okay, okay va, so idhila irundha I'm just removing a part. Okay, I'm just removing a part. So how I'll be finding the right now what is the moment of inertia, adu vandu find pandrathu eppadi simple ah iruke. So first object oda mass vandu I'm taking it as m1, which means nama total and the disk oda mass vandu I'm just taking it as m1. adoda center of mass oda position vandu I'm just taking it as r1. Till this understood? m1 and r1. So removed part oda mass vandu m2, idoda center of mass oda position vandu I'm taking it as r2. அப்படினா அந்த center of mass, the new object oda illana அந்த removed part and the remaining part oda center of mass vandu you can just find it in this way. Okay, got it everybody? Understood? Please let me know with a favorite pink heart everybody. It has been a long time I didn't ask a pink heart. Give me pink heart everybody. Paka. Okay, so now we are going for the motion of center of mass da. So 𝐕𝐶𝐼𝐚 will be m1 v1 plus m2 v2 plus m3 v3 etc divided by m1. So m1 v1 சொல்லும்போது we know that is nothing but p1 நம்ம momentum da. Wow, it looks so beautiful, so pretty. Okay, so in the madri acceleration 𝐴𝐶𝐼𝐚 irukku. And also we know that if the center of mass oda position change aganumna adukku vandu external force apply pannanum, illana center of mass vandu change agadu. Okay va, so that is again another important thing. So inga vandu pathena m1 a1 சொல்லும்போது f1 da plus f2 plus etc divided by the total mass. Okay va, understood guys, everybody? So next one the nama torque or expression da. Torque one it is nothing but r cross f, which is nothing but rf sin theta. Next one the angular momentum, the angular momentum one the r cross p. Also we have another equation after moment of inertia. We will study one more equation for angular momentum. For the continuous bodies it will be I omega. Then the torque and the angular momentum relation, we know that it is nothing but dl by dt. Okay, dl by dt. Exactly f instead of torque and p instead of l we will introduce. So next one I think moment of inertia. Okay, equilibrium da, that is also we know. Ipo on the translational equilibrium சொல்லும்போது external force will be 0, and if it is rotational equilibrium then torque should be, the net torque should be 0. Got it, everybody? Understood? Please let me know guys, everybody. Yes or no, yes or no, yes or no? Okay, so this is what the equilibrium of a body. And again in the translation la we have already discussed static irukku, dynamic irukku, so that also you guys know it. So next one the pathena nama moment of inertia da. Okay va, moment of inertia da. So moment of inertia சொல்லும்போது for discrete particle it will be mr square da, and also for the continuous bodies it will be r square dm da. And also adukapram radius of gyration. What is radius of gyration da? So ipo vandu oru object irukke, and oru object la I'm just considering a particular axis, and the axis la irundha I can just find some other point la the entire mass concentrate pannirukra innoru point I will get. So in the axis la irundha and oru point varaikku irukra distance da vandu radius of gyration, which will be coming as root of I by m. Radius of gyration is important, sometimes it is asked as well. Next one the parallel axis and perpendicular axis theorem. You people will say, because I'm done with this, because many times almost every class la vandu we were discussed this parallel and perpendicular axis theorem, right? Guys marakama like panikoda. Parallel axis theorem na adukku vandu it can apply for 2 dimension, 3 dimension, 1 dimension, for anything. Ana vandu condition enna, one axis should passes through the center of mass and axis should be parallel, two axis should be parallel irukkanum. So appadina what will happen da, inga vandu enakku irukkiradhu ring da. So through the diameter, which means through the center of mass, it is mr square by 2 da. If I wanted to find it moment of inertia at this point, at this axis, then what I will do, I will use the parallel axis theorem, which means mr square by 2, which means 𝐼𝐶𝐼𝐚 plus md square. What is d? What is d? In the two axes kulla irukra distance da. What is going to be in this case? It is nothing but r da. So I'm going to get mr square. So this is how we will be finding the parallel axis theorem. And perpendicular axis theorem varumbodhu it is only applicable to the two-dimensional object. It is not valid for 3 dimension and 1 dimension. It is only for the 2 dimension. And what is the thing? Let us say inga vandu ring irukke. Okay, in the ring is xy plane la da irukke. Appadina I could say that ix plus iy, which is equal to iz. So let us say ipo vandu in the ring is in the yz plane la da irukke. Appadina how you will write the perpendicular axis theorem? In the ring vandu yz plane la da irukke. Appadina how you will be using the perpendicular axis theorem? Quick, let me know. I will wait for your answers, then only I will go for it. Everybody. Perfect. Iy plus iz, which is equal to nama ix, it will come. Very good, Fatima. Very good, Divya, Jahi, Ramya. Ramya, why you deleted that? Wrong. Okay. So yes, fine. I hope it's clear. Now let us move on to the next one. Ready now? Quickly put some fire, da, everybody. Everybody put some fire. So இது வந்து few moment of inertia that is mandatory for you people have to study. I'm not saying like other moment of inertia தேவையில்லை அப்படி இல்லடா, இது வந்து mandatory தான், necessary. Okay, 90% will be this one, the rest will be 10% தான். Got it? So you guys have to study this. If you want it, you can just take a screenshot. I will move from this. Guys, like பண்ணுடா. You people are not liking the session. Yes, took ma'am. Perfect. So next on the pathena, we already discussed about the torque and linear momentum and everything. Now we were just rewriting those equations in terms of moment of inertia. So torque code equation enada, I alpha da, and angular momentum enna, I omega da, kinetic energy enna, half I omega square da, which will be L square by 2I. We can just write in terms of what nama angular momentum thoda term la kuda we can just write. We just write no linear kinetic energy. We will say na P square by 2M. So on the madri P will be replaced as L, M will be replaced it as I. Avloda. And work done will be integral tau theta and power will be tau into nama angular velocity. Understood everybody? Yes or no? Yes or no? Please let me know. Because yena vanda we have only one more topic left in this topic, which is nothing but conservation of angular momentum. What is conservation of angular momentum? Exactly how we have discussed the linear momentum. So linear momentum enna sollitanda, external force is equal to 0 na dp by dt will be 0. Appadina dp will be 0, which means the pi will be equal to pf, which is represented as P is constant. Appadina inga vanda I will just replace all the terms. If the net torque is equal to 0, dl by dt will be coming as 0. dl by dt is 0, then dl will be 0. Appadina li will be equal to lf, which means L will be constant. Okay, done everybody? Understood? Guys, please let me know. Put some fire if you understood till this. Everybody? Waiting for your response, guys. Pakka. Perfect. All good. Yes, very good, guys, very good. So shall we go for gravitation? Are you guys ready for gravitation? Crystal clear. Thank you, Fatima. Yes. Perfect. So, appadina, let us start with the gravitation. Okay. So, gravitation, first one is the universal gravitation constant, which is nothing but Gm1, okay, visible, Gm1 m2 divided by r square. Okay, va? This is the gravitational force order expression. And let us say, if we are keeping 2 point masses, okay, if we are keeping 2 point masses in 2 different medium, okay, first one I will keep in air, another one I will be keep it in water. So how the force will be affected? How the force will be affected? Please let me know how the force will be affected. I wanted to know, guys, how the force will be affected. First one I kept it in air. Adukapram I am just keeping in water. Same point of mass, same distance of separation. How the force will be affected? You should tell the answer. Otherwise, I won't go for the next step. I will wait. No worries. And be an eye on your the like button. Still, it is blank. Make it dark. I'm not getting any chats. Why so? What happened, guys? Why it is not coming? Hey guys, very good, Jahi, very good. It does not depend upon the medium. Okay, so even if we are keeping the same system of point masses in water, in oil, wherever it may be, it is not going to change. ஏனா வந்து நம்ம force is independent of the medium da. புரிஞ்சுதாடா everybody? I hope everybody understood. So next வந்து பார்த்தேனா நம்ம acceleration due to gravity da. Acceleration due to gravity சொல்லும்போது which is nothing but gm divided by r square da. அப்படினா we know that mass சொல்லும்போது என்னடா mass என்ன density into volume da. So I'll be writing 4 by 3 pi into r cube. So I can just rewrite this equation of acceleration due to gravity which is given in which is given as the second equation in terms of density. Okay, depending upon the question what is given adu use panni you can just use any of the equation. Next one, we know that in the acceleration due to gravity will definitely change with respect to height, with respect to depth and all. So adoda equation da. So let us say if the height is too big, okay, comparing with the radius of the earth. Radius of the earth na 6400 kilometer da. So let us say in the value and in the h oda value height one I am taking more. Okay, it is actually comparable with the what to say radius of this earth da. And the case la nama what to say nama acceleration due to gravity we will mention like this: g into r divided by r plus h the whole square. Ana vanda let us say if it is less than 320 kilometer, which means h oda value vanda it is less than that of 320 kilometer. Why ma'am in the 320 kilometer? Yena vanda 5% of the what to say nama radius of the earth value da in the 320 and the 320 kilometer vida lesser da. Okay, h value vandu less na mattum da you can go for this equation. Yena vandu students will be get confused during the exam time which equation I should use, and many students even if it is more than 320 nalum they will go for this equation. Ana vandu answer vandu wrong ah irukum, and you in the oru equation use panni you will be getting an answer na, and the answer it will be there in the options also. So we will feel like we will become very confident. Okay, எனக்கு வந்து answer கிடைச்சிருக்கு, ஆனா வந்து அது வந்து wrong தான். If it is more than what to say in the 320 kilometer or let's say more than 5% of the total radius na you should go for the first equation. If it is less then you can go for the second equation. Next வந்து depth base பண்ணி தான். Okay va, till this understood? Can you give me a pink heart everybody? So when I'm talking about this depth, nama acceleration due to gravity varies as g into 1 minus d by r. Always just understand depth சொல்லும்போது இதுதான் வந்து center. Okay va? So depth சொல்லும்போது இந்த surface ல இருந்து இருக்கிற distance தான். Okay va? Surface ல இருந்து how much is the depth? That is what d value. Yes da, thank you guys, thank you so much. Okay va? So we will be get it as g into 1 minus d by r it will come. So now let us go for the next part. Next part na nama gravitational field intensity da. So those who have studied okay electrostatics la we have discussed all the equations. Adula vandu just we will replace with the constants. Okay, so anga vandu k na inga vandu g, anga vandu q na inga vandu m. So nama gravitational field intensity will be coming as gm by r square da. And solid sphere சொல்லும்போது solid sphere consider பண்ணிட்டேனா அதுக்குள்ள solid sphere, why we are studying solid sphere here? Because earth வந்து ஒரு solid sphere தான், ஏனா earthக்குள்ள mass இருக்குல்ல, it is not a hollow sphere. So அதனால தான் we are studying this is important. So for solid sphere it will be coming as inside it will be g into m into x divided by capital R square it will come, which means the field intensity will increase. Okay, the field intensity will increase. This is R, this is E. So E will be proportional to X da. Till what time? Till the what to say nama R value vandu equal to R vara varakum it is actually increases. Adukapram enna agumda? Adukapram enna agum? It will reduces. Outside you can see gm by r square. So it will be reduces as E is proportional to 1 by r square. In the graph kuda important ada, because ena vandu sometimes in the graph they have asked. Guys, don't forget to like the session. Understood? Got it? Solid sphere vandu purinjiruchuna, can you give me a blue sky? Everybody give me a blue sky in the chat box. So solid sphere la inside, outside and the surface. Exactly ditto equation da electrostatics lume. Just we need to replace. Enga we have m, anga vandu we will replace it as q. Where you find k, anga vandu we will be replace it as g. Okay, so now இது வந்து extend ஆக போறேன்டா. Okay, don't worry, we will extend. Okay, next one is spherical shell தான். Spherical shell சொல்லும்போது hollow sphere. So அதுக்கு கூட same exactly outside and surface ல same equations தான். So now if I'm just, this is for solid sphere, this is for solid sphere. Now I'm going to plot for the hollow sphere. Okay, this is for hollow sphere. So hollow sphere சொல்லும்போது என்ன ஆகும்டா, என்ன ஆகும், இங்க வந்து E இருக்கு, இங்க வந்து R இருக்கு. So outside part is same, from the surface to the outside part is same. So let us say this is what நம்ம R radius. So இந்த ஒரு partல there is no confusion, இது வந்து it is proportional to 1 by R square தான். Hollow sphere ல inside the earth surface what will happen? Hollow sphere ல inside the surface what will happen? Hollow sphere la inside the surface. Quick, let me know. There is no mass. Mass illana, field intensity is going to be 0. So I'll be getting a graph like this. In the graphs vanda romba important da. Do not miss this as well. So next vanda nama potential da. Field and potential order relation is given. E is equal to minus dV by dr da. Very good Jia, very good Ramya, very good. So now gravitational potential due to a point mass will be coming as minus gm by r. Why always that minus sign? Why always that minus sign we have? What is the reason? It is only due to the attractive force. எப்பவுமே நம்ம gravitational force வந்து always attractive in nature. So whatever be the potential, field, everything, there will be a negative sign. Okay va? And potential energy வந்து gm1 m2 divided by r it will come. Okay vada? So solid sphere order potential and the potential energy is given, so that also you can just go for it, which is not that important. Okay, I won't say you can skip it, but it is not that much important. Next one நம்ம escape velocity da. What is escape velocity? நம்ம earth surface ல இருந்து if you wanted to go to, okay, இந்த gravitational field வந்து எனக்கு experience பண்ண வேண்டியது இல்ல, I wanted to go away from this earth na, you should have a minimum velocity. அந்த minimum velocity தான் நம்ம escape velocity. அதோட equation is also important. இந்த mass வந்து you can again replace in terms of density, so you will be getting this escape velocity as r into root of 8 pi rho g divided by 3. இந்த equations எல்லாமே வந்து don't by heart and all, ஏனா வந்து we know that just we need to substitute the value of m. Okay, அது வந்து we know rho into v da. So just substitute and just find it. And what is at the earth surface la என்னடா value? Escape velocity ஓட value என்ன earth surface la? அது வந்து 11.2 kilometer per second da. Many students used to say per hour. It is not per hour da. Per second la it will go, I mean the object should go 11.2 kilometer. Understood? So kilometer per second da actually வந்து நம்ம escape velocity ஓட equation. So next வந்து motion of satellites da. பரவாயில்லடா ஃபாத்திமா, no issues, no issues. Okay, so motion of satellites da. Very good Ramya, very good. Okay, so motion of satellites சொல்லும்போது அங்க வந்து orbital velocity is nothing but ve, escape velocity divided by root 2 da. So you'll be getting root of gm by r. Next one the time period. The time period will be 2 pi r divided by orbital velocity. Next one the energy order relation. So as you guys know, the connection potential energy will be equal to total energy. Okay, wow, total energy. How? What is the relation? What is the relation? Potential energy will be 2 times the total energy. And also potential energy will be minus 2 times the kinetic energy da. So potential energy oda equation we already know it, gmm divided by r da. So idhila irundhu you can find the total energy, you can find the kinetic energy. So just study this relation, ena vanda in the relation is applicable in all the chapters, and then study the potential energy because you can just find the rest of the values as well. Understood everybody? Can you give me a fire if you understood everybody? So next வந்து நம்ம Kepler's law da. Kepler's law la first law என்னடா? All planets will be revolving around the sun in a elliptical path la da actually வந்து it is moving. Second law என்ன? Law of areas da, which means dA by dt. dA by dt na என்ன? Areal velocity, which is going to be constant, and அதோட value வந்து L by 2m da. Next one the third law. Third law என்ன? T square will be proportional to நம்ம cube of the semi major axis. So it will be T square will be proportional to a cube it will come. So இத base பண்ணி numericals கூட வரதுக்கு chances இருக்கு. So you guys have to study this as well. Understood everybody? Can you please let me know guys? Can you please let me know through your favorite heart? Give me a red velvet quickly. Everybody. 1 hour over. Okay, not 1 hour. Da. Okay, so let us do one thing. Da. We can just take a break. Okay, I think you can go for a lunch break. Okay, adukapram we can just continue. Da. Nama next session will be anyway konja late da start panna poro. So let us just go for a lunch break. So 20 minutes enough, Ada? 25 minutes. 25 minutes. Is it okay for you people? But you should come back. Okay, if you guys are not coming back, I will never continue this. Because yarikaga I'm doing it. Only for you people, right? Lunch kapram, okay ma'am, I will go for sleep. And the madri sollitena. You are wished, Dora ma'am. Okay. Okay, so let us do one thing. Till 1:25 varakum we can just take a lunch break. Okay, va? So thank you guys. We'll see you after the break. Hello, 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 everybody. Am I audible? Yes. Start panlamada. Everybody ready? Put some fire if you are ready. Everybody, because we are going for the solids chapter. Let me know in the chat box. Everybody. இல்லடா லஞ்ச் சாப்பிடல இந்த செஷன் முடிஞ்சதுக்கு அப்புறம் I will go and I'll have because இன்னைக்கு கூட I didn't bring lunch da. I have to order something. So I ordered, it will come after the class, I guess so. Okay, so let us start. Let us start. Yes, perfect, perfect, perfect. So we are going for the solids chapter. So adula vanda stress irukke, strain irukke. So tell me the equation. What is stress? What is strain? Yes, everybody is waiting to finish the class, Ada, to have lunch. Then why I have given the lunch break? Okay, so yes. So yaravadu edachu special? Anybody had anything special? Chicken biryani and something like that. Anybody has had anything? Yes, yes. F by A. Very good, Ashiga. Raman, very good. No, ma'am, just finished breakfast. Okay, okay. Late breakfast, late lunch. Paravalla. Okay. I ate chicken, ma'am. Damya, now I had nuts and drink water. Okay, very good, very good, very good. So in the last 3-4 days, just try to be healthy all the time because it is very important to be healthy last few days. ஏன்னா வந்து நமக்கு எனர்ஜி இருக்கணும், ஹெல்த்தியாக இருக்கணும், then only we can just concentrate, we can focus. ஏன்னா வந்து இந்த டேஸில் we are going to what to say refill a lot of things. அது வந்து அங்கேயே ஸ்டோர் ஆகணும்னா அதுக்கு வந்து அவ்வளோ கான்சன்ட்ரேஷன் அண்ட் ஃபோக்கஸ் இருக்கணும். ஸோ அதுக்காக we have to be very ஹெல்த்தியாக இருக்கணும். ஓகே, ஹெல்த்தி ஆகிறதுக்கு don't go for any fast food, don't go for any kind of what to say fried foods and all. In the exam முடிஞ்சதுக்கு அப்புறம் you can go for, you can have anything whatever you want. Okay, just sacrifice for the rest of the few days. அதுக்கு அப்புறம் fine. Okay, we have just now only started. No worries, no worries. Me too, chicken after class. I will also have chicken after class. Aha, same pitch. Okay, so I logged into my mom account, my phone fell in water. Oh my god, Krishna. Oh my god, no one has told anything. Oh my god, if this happened in my home, I will be somewhere right now. Okay, so now just start da. இப்போ வந்து நம்ம ஸ்ட்ரெஸ் இருக்கே, ஸ்ட்ரெயின் இருக்கே. So something was happened to my eyes. ஒரே பெயினா இருக்கு. Maybe due to the light, bright light. So all full of lights here. Maybe because of that. ஒரே பெயினா இருக்கு. So right now நம்ம stress strain da. Stress na வந்து நம்ம restoring force divided by area da. Strain na it is nothing but change in dimension divided by original dimension. Okay va? So right now நீங்க வந்து பார்த்தேனா நம்ம stress and strain la we have 3 types. Okay, longitudinal stress, longitudinal strain, volumetric stress, volumetric strain, and the shear stress, shear strain. So அதோட equations தான் இங்க இருக்கு. So இப்போ வந்து strainல there is no issues. delta L by L and இங்க வந்து delta V by V, இங்க வந்து delta X by L தான். So we can also say that is equal to approximately equal to tan theta இல்லைன்னா theta. Okay, if theta is very small, we can just convert. So next வந்து என்னன்னா நம்ம Hooke's law தான். What is Hooke's law? Hooke's law is nothing but stress into strain will be, okay, stress is proportional to strain, which means if I'm just plotting stress versus strain na, it will be a straight line. Okay, so it will be proportional. So the thing is like there is, I mean, when we are talking about Hooke's law, we should mention one thing within the elastic limit. Okay, beyond this elastic limit, Hooke's law is not valid. So just not panikoda. So we were talking about Hooke's law. Hooke's law na stress is proportional to strain da. So இப்போ வந்து பார்த்தேனா this is valid in the elastic limit. Okay, in the elastic limit la mattum da actually வந்து it is valid. Next வந்து பார்த்தேனா நம்ம different modulus of elasticity da. ஏனா வந்து when I'm just talking about stress by strain இல்லையாடா, when we told that stress is proportional to strain, so now I'm taking the strain over here. Okay, strain over here. So then what will happen? Stress by strain will become a constant. And the constant தான் வந்து நம்ம elastic, I mean modulus of elasticity. அதுல வந்து 3 things இருக்கு. Young's modulus இருக்கு, bulk modulus இருக்கு, and also என்னடா Noda. No. I won't go up to 3 and all. This is almost done. No, the rest of the chapters were the small chapters. Da. So stress by strain, which is equal to nama modulus of elasticity. Da. So now you can see here nama Young's modulus. So Young's modulus it is nothing but longitudinal stress divided by longitudinal strain. Just study this equation, F divided by A into delta L. Delta L na the extension happened and A na nothing but the area. Da. So next one the நம்ம bulk modulus தான். bulk modulus சொல்லும்போது நம்ம volumetric stress divided by volumetric strain தான். So அப்படினா you will be getting, okay, so actually வந்து சொல்லும்போது we will be get it as F by A divided by delta V by V தான். So இதுல வந்து force by area, இது வந்து liquid நால, okay, it is actually coming in the category of liquid இல்லனா fluid. So definitely what will happen in the F by A, இது வந்து what is in நம்ம force வந்து it is going to be normal force இருக்கும். So we can just replace F by A as the the pressure. So you will be getting pressure divided by delta V by V. Okay, stress you can just write it as pressure. So now you will be getting this equation minus V into delta P divided by delta V it will come. Okay, Vada. So right now this is what the bulk modulus. Next one we have the modulus of rigidity. Okay, modulus of rigidity சொல்லும்போது நம்ம shear stress divided by shear strain da. Shear stress we have already mentioned, அது வந்து we can just mention it as F by A. Strain வந்து we said delta X by L, இல்லனா we can just represent it as theta. So we will be getting F by A theta as the answer for modulus of rigidity. Another one term is nothing but the compressibility da. Compressibility la என்னடா, it is actually the reciprocal of the bulk modulus da. So in the equations எல்லாமே வந்து very important da. So right now let us just go for the stress strain graph. Do you remember this? Do you remember this? So up to a limit it will be obeying the Hooke's law da, which means it will be directly proportional. Then what will happen? Then what will happen da? There is a point, okay, ultimate tensile stress. What is that value? What is that ultimate UTS? What is UTS? UTS nana the maximum value which is possible for the stress. Okay, and the material maximum value enna irukku, that is what the ultimate tensile stress point. Okay, so that is also very important. And also adukapram pathina, one second everybody, just give me a second. Okay, so there is a problem, guys. I have to wind up the session in 5-10 minutes. Okay, max to max I can go for 10 minutes because nama vetri bachelor adoda class irukku. I forgot about that. So that is the one problem. So we will extend for, I think we can just finish this and we can just wind up the rest of the chapters. We can just do it on some other day. That is what I can do. Illana idoda notes vandu ungalku kedaikum. So idu vandu precise ana notes da. So you can just go for you can just go through those notes. Or anyway in the part 2, let me just check the slots vandu free ah irukna. Definitely I will go for the part 2. Okay va, இன்னைக்கு evening slot vandu booked ah irukke, which means நம்ம 600 plus irukke. So நாளைக்கு வந்து பார்க்கலாம்டா, I will just inform. Okay, in the batchல வந்து delay ஆகாது. So that is what I got the notification. I also forgot about the class. I was thought like I can go up to 2:30, but I can't da. So sorry. So let me just check the part 2 வந்து I will try my best. இல்லனாலும் இந்த notes வந்து you just manage. Let me just check. Okay, the session முடிஞ்சதுக்கு அப்புறம் straight I should go for that test, that session. Adukapram I will just confirm you da. In the comment box I will just confirm when I can just go for this part 2. Okay, so sorry guys, so sorry. Okay, so in the ultimate, when we were just talking about, okay, when we were just talking about the stress and strain graph, here is the graph. Okay, so now you know that you will be having I mean nama hooks la obey பண்ற ஒரு region இருக்கும். அதுக்கு அப்புறம் பார்த்தேனா it will be something like this. So இதுல வந்து maximum point தான் நம்ம UTS. UTS na I have already told you the ultimate tensile stress point தான், which means அந்த ஒரு பாயிண்ட்ல தான் அந்த மெட்டீரியலுக்கு maximum stress கிடைக்கும். So இங்க வந்து another point இருக்கு. Let me just call this point as A and this point as B. I'll tell you why I'm just specifying this. இந்த point A and B இருக்கிற distance வந்து ரொம்ப important தான். Okay வா? Do you remember anything? Do you remember anything? Ma'am, please reply PDF not uploaded. Yes, da Fatima, in the I mean, இன்னைக்கு வந்து 6 PM க்கு there is another video will come. Okay, அதுல வந்து mind map formula everything combined I have done a video. Okay, and the video வந்து it will be public around 6 or 6:30. So on the time you can just download from there. ஏன்னா வந்து many students were asking. Okay, so அது வந்து sessionல I have mentioned. ஏன்னா வந்து இந்த இதுக்கு முன்னாடி கூட I have done it, but அது வந்து studentsக்கு they couldn't download. So I was just felt like I can do it as a separate part. Okay. So now in the A and B points, okay, A and B points da. So in the A point வந்து ultimate tensile point da. So in the point ல இருந்து நம்ம fracture point, நம்ம B point da fracture point. In the fracture point and ultimate stress point is I mean actually அதுக்குள்ள distance அதிகமா இருந்துச்சுனா we will say that is actually ductile. Ductile na என்னடா meaning? Ductile na என்ன? We can just make it to thin like gold. Okay, gold we can just make it into a very narrow. Okay, அதோட thickness வந்து அவ்ளோ ஸ்மாலா we can just make it, right? So அதனால we can just say that இப்போ வந்து இந்த AB ஓட length வந்து if it is more na, okay, and the distance வந்து more na, we can say that அது வந்து ductile தான். இப்போ வந்து அதோட distance வந்து கம்மினா, let us say I have another graph over here, let us say, so இந்த மாதிரி தான் actually வந்து நம்ம graph இருக்கு. Okay, so இது வந்து A, this is what B. So இப்போ வந்து அந்த ஒரு distance வந்து கம்மியா இருக்குல comparing with this. So just comparing with this two graph, I can say that this is more ductile than this one. This is going to be more brittle, which means even if I'm just giving more stress na, what will happen? It will be get damaged. Purunchada everybody understood? Can you give me a blue heart quickly, everybody? So we are going for the next topic, which is nothing but elastic potential energy in a stretched wire. This is again even more important da. So actually வந்து நம்ம potential energy will be coming as the elastic potential energy stored will be half into F into delta L da. Okay va, half into F into delta L da. So right now I'm just removing all the negativities right now, just because I wanted to finish this. ஏன்னா next class ல போணும்ல, அதனால தாடா, sorry. Okay, if they're disturbing, just close your eyes da. I can't do right now. Okay, so நம்ம potential energy வந்து half into F into delta L da. But students வந்து எப்பவுமே they will be get confused with this equation. When we will say U is equal to half into stress into strain, when it is the what is the potential energy per unit volume na, we will say that half into stress into strain. If there is, okay, if we need to find the potential na, it is actually half into stress into strain into volume, or otherwise you can go for half into F into delta L. Don't be get confused. Question la just clear note paniko what is given. The energy illana energy per unit volume. In the two equations it is two different quantities. Idu vandu potential energy, idu vandu potential energy per unit volume da. So don't make any kind of mistakes da, which is very very important. Adanala I'm telling you, okay, ஏன்னா in the solids chapter la irundhu avlo easyana questions vandu we can expect. Okay, so the easyana questions la many students vandu making a mistake because of this small thing. Okay va, புரிஞ்சுதாடா? So this is what about our solid chapter. So next one the fluids da, adu vanda let me just check the availability and everything. If I'm getting any slots free, I will just go for this part 2 as well, no worries. Illanalum in the notes irukenda, in the notes vanda I will just upload after the class. So the notes vanda download panika, you can just go for I mean you will be getting a precise note da. So last minute la revision ku idu vanda romba helpful ah irukum. Okay va, so let me see இந்த session முடிஞ்சதுக்கு அப்புறம் தான் எனக்கு வந்து schedule பார்க்கணும். Okay, schedule பார்த்தாலே எனக்கு தெரியும் like where is the free slot coming and all. Okay, so that's the thing da. And also in the what is in the class முடிஞ்சதுக்கு அப்புறம் we will be having the what is it நம்ம what is it I forgot. I'm tension la இருக்கு, இதுக்கு அப்புறம் class இல்ல, tension la இருக்கு. Okay, so இதுக்கு அப்புறம் நம்ம my test இல்ல, okay, நம்ம free Re-NEET crash course தான் இது. So இதுல வந்து by now, if you are just going for by now, you will be getting the what is it நம்ம free ஃப்ரீ ரீநீட் கிராஷ் கோர்ஸ் வந்து கிடைக்க போகிறோம். அதுக்கப்புறம் யூ வில் பி ஹேவிங் த நம்ம அதில் வந்து மை டெஸ்ட் ஒரு ஆப்ஷன் இருக்குது. அந்த மை டெஸ்ட்டில் இந்த கிளாஸுக்கு அப்புறம் ஒரு எக்ஸாம் இருக்கும். அந்த எக்ஸாம் வந்து யூ கேன் ஜஸ்ட் அட்டெண்ட். எஸ், போஸ்ட் கிளாஸ் டெஸ்ட். எஸ் ஃபாத்திமா. ஓகே, ஐ எம் ஆல்சோ ஃபீலிங் வெரி 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 டிசப்பாயிண்டட் பிகாஸ் எனக்கு வந்து இந்த பிகாஸ் ஐ எம் வெரி மச் கான்ஃபிடென்ட் இன்னொரு 1 hour 15 minutes இருந்துச்சுன்னா டெஃபினெட்லி we can just finish the rest of the chapters as well. ஏன்னா வந்து it is not a kind of a big chapters. Everything is just precise. We can explain everything. Okay, torque full twisting for ஆமாடா. ஓகே, ஸோ தேங்க்யூ ஸோ மச் கைஸ். தேங்க்யூ ஸோ மச். மெனி ஸ்டூடெண்ட்ஸ் வர் தேர் ஃப்ரம் த பிகினிங். அது வந்து ரொம்ப வாட் இஸ் ஐ ஹேவ் டு அப்ரிஷியேட். ஏன்னா வந்து இது வந்து ஒரு ஒன் வே கிளாஸ். தெர் இஸ் நோ கொஸ்டின்ஸ், தெர் இஸ் நோ சச் இன்ட்ராக்ஷன். ஐ வாஸ் ஜஸ்ட் கீப் ஆன் டாக்கிங். ஸோ ஐ வாஸ் ஜஸ்ட் ஃபெல்ட் லைக் இட் வில் பி ஓகே, இது வந்து ஆக்வர்டாக இருக்குங்க கிளாஸ், வந்து ரெஸ்பான்ஸ் வராது அப்படி ஐ தாட் இஸ். பட் டெஃபினெட்லி மெனி ஸ்டூடெண்ட்ஸ் நம்ம ஃபாத்திமா, ரம்யா, திவ்யா, கிருஷ்ணா, ஸோ ஷமிதா, then who else was there? Ashika. Yes, many students. Did I miss anyone's name? Okay, many more students are there. Yes, Jia, sorry, Jia also there. Yes. Okay, so thank you so much guys, thank you so much. Tanu, you came now only. I know. Okay, da, so just watch this part and the rest of the part I will try to do it and I will just upload. Okay, so thank you so much. Bye, see you. Da, Divya, sorry Divya, I forgot your name. Sorry da. Thank you, bye. Sorry, Ojjal, not Divya. Oh my god, still I'm getting confused da. Ojjal. Sorry da. Thank you guys, bye.